Picture yourself beneath a quiet night sky. The air is still, the horizon softened by shadow, and above you hangs the moon, pale and familiar, yet somehow distant. It feels steady, almost eternal, like a lantern that has never gone out. For thousands of years, human beings have looked upward and trusted that it would be there, rising and setting, shaping tides, watching over nights both calm and stormy. But as quiet as it appears, the moon is not as simple as it looks. Hidden inside that glowing disk is a story of strange events, unanswered questions, and a few mysteries that sound almost playful in their defiance of what we think we know. If this calm journey through the forgotten secrets of the moon brings you comfort, you can gently support this channel by liking and subscribing. That way, more of these quiet stories can drift your way, like moonlight slipping through a window. Let us begin where the silence was broken. In November of 1969, astronauts of Apollo 12 left more than footprints in the dust. They left behind instruments, the kind designed to listen to a world that doesn't seem like it should have a voice. Seismometers, machines that register vibrations, were planted carefully on the lunar surface. Once their work on the ground was complete, the astronauts rejoined their command module in orbit. But instead of leaving their discarded lunar ascent stage to drift aimlessly, they gave it one last task. They directed it to crash into the moon. The idea was simple. If you strike a world and measure the waves it sends rippling through its body, you can begin to understand its insides. On Earth, earthquakes taught us about the molten core and shifting plates beneath our feet. On the moon, there are no oceans, no winds, no tectonic bustle, only stillness, rock, and dust. So what could possibly happen when metal slammed into stone? The answer was stranger than anyone expected. When the module hit the moon's surface, the instruments recorded vibrations. Not surprising. Impact always leaves an echo. But this echo was no ordinary thud. It lasted. It shimmered on the readouts for nearly an hour. Scientists described it in language that has become famous. The moon rang like a bell. Now, it wasn't sound in the sense of music echoing across the air. Space is silent, after all. But the seismic reverberations behaved in ways unfamiliar to geologists. On Earth, tremors spread and die quickly, absorbed by liquid layers and shifting rock. On the moon, the waves just lingered, as though the body beneath the surface was rigid, dry, and unwilling to let go. Imagine tossing a pebble into a pond and seeing the ripples continue, endlessly circling, long after the stone has sunk. That was the riddle Apollo handed to scientists. Why did this world refuse to quiet itself? The ringing wasn't a one-time curiosity. During later missions, when boosters or equipment were allowed to crash, the moon once again echoed with those slow, resonant tremors. Each time, the seismometers confirmed what had been whispered before. The moon was not the dead, dull rock ball many assumed. It was something else, something stiff, something built in a way that did not quite match our earthly expectations. Part of the answer lies in what the moon lacks. Earth's insides are restless, churning with molten iron and moving plates. Heat is carried, stored, and released. But the moon's smaller and colder. Long ago lost its inner furnace. Its crust and mantle are dry and fractured, like ancient clay left too long in the sun. Without moisture, without ongoing volcanism, there is nothing to soften the passage of seismic waves. They simply ricochet, bouncing through hollow fractures, ringing and ringing as though trapped in stone corridors. To some, that dryness seems like a cosmic quirk. To others, it's a key. The way vibrations travel can reveal the structure of a world, its layers, its density. even whether molten secrets still glow in hidden chambers. The moon's long echoes, odd as they sound, offered scientists their first deep glimpse beneath the gray dust. And in that glimpse, a stranger picture emerged, a crust surprisingly thick, a mantle dry and brittle, a core far smaller than once imagined. Of course, when humans encounter something that rings like a bell, imagination tends to race ahead. Conspiratorial whispers rose. Perhaps the moon was hollow, an artifact rather than a natural body. After all, what natural world rings like metal? Such ideas were never embraced by mainstream science, but they added a layer of folklore to Apollo's data. The quiet moon, it seemed, had learned how to keep secrets. Yet the scientific puzzle remained. How had such a strange companion formed? Earth and moon are locked together in a gravitational embrace, so precise that eclipses line up with uncanny perfection. One orbits, the other tilts, and somehow life here thrives. For centuries, people assumed the moon had simply been captured, a wandering rock caught by Earth's pull. But the math never quite added up. Captures are messy. Imagine throwing a baseball out of a car window and having it spiral neatly around a lamppost. Not impossible, but very unlikely. The leading theory today suggests a far more violent birth. Roughly 4.5 billion years ago, a Mars-sized body, often called Theia, may have collided with young Earth. The impact was catastrophic, tearing away molten material that eventually coalesced into the moon. It's an image almost too dramatic to picture. Oceans of rock vaporized, the sky raining liquid stone, Earth reshaping itself as its shattered pieces cooled in orbit. Out of destruction came companionship. But even here, mysteries remain. Some scientists argue that the chemistry doesn't fully match, that perhaps the moon was pieced together from multiple impacts rather than one grand collision. Others wonder if smaller moons once circled Earth, merging over time into the single presence we know. Still others suggest that droplets of molten rock condensed from vapor clouds, creating a body less like a singular child of catastrophe and more like a quilt of orbital debris. None of these theories is perfect, and perhaps that's part of the moon's enduring allure. It resists our attempts to explain it neatly. While we puzzle over its origin, the moon has been quietly drifting away. Each year, it recedes from Earth by about 3.8 centimeters. That may sound tiny, like the slow crawl of a fingernail, but over millions of years, it reshapes the relationship between Earth and sky. When it was closer, it loomed larger, pulling tides to greater heights, glowing almost like a second sun in the night. In the distant future, it will appear smaller, too small to fully cover the sun during eclipses. The total eclipses we marvel at today, a perfect alignment where the moon blots out the solar disk, are only possible in this brief geological moment. Think about the odds. Billions of years passed, billions still to come. And we live in the slender window where the moon and sun share just the right sizes and distances to create those rare rings of fire in the sky. A cosmic coincidence, almost comedic in its timing. It's as if the universe saved the best seats for us, right now, before the show moves on. And yet, while it drifts, the moon continues its stabilizing work. Earth tilts on its axis, but the moon's pull steadies that tilt, preventing wild swings that could whip climates into chaos. Without it, Earth's seasons might lurch unpredictably, resetting ecosystems before they could mature. Forests might never have grown vast. Civilizations might have found the climate too unstable to rise at all. In its silent orbit, the moon has been more than a companion. It has been a guardian of time itself, buying our planet the stability needed for life to flourish. The moon's stillness is deceptive. It looks frozen, but it has shaped the most delicate rhythms of our world. Its pull is written in the tides, its distance measured in the length of our days, its patience embedded in the climate that allowed humans to plant, build, and dream. And all of it began with that silent ringing. When we first realized this pale lantern was not just a stone in the sky, but a complex, shifting partner whose mysteries linger like echoes. Stand outside on a clear night and notice how the moon never changes its face. For all of human history, it has gazed down at us with the same arrangement of dark patches and pale highlands, as if it were carved to hold that expression forever. The side we see has become a canvas for stories and myths, the man in the moon, the rabbit, the goddess. But always the same face, locked in quiet companionship. What we rarely think about is what that means. The moon is tidally locked to Earth, a perfect balance where it rotates just once for every orbit it makes. The far side exists, but it never turns to greet us. It stayed a mystery until the space age, when satellites finally peered over the lunar shoulder. And what they found was strange. The far side is nothing like the near side. While we are familiar with the wide dark seas, the lunar maria, that cover vast stretches of the near side, the far side is heavily cratered mountainous and lacking those great lava plains. It is scarred and battered, a harsher face hidden from us. For centuries, we told our stories based only on half the truth. Humanity's relationship with the moon is, in a sense, a story of bias. We built culture, calendars, and even romance on the side we could see, never realizing the other half was utterly different. This asymmetry puzzled scientists. Why should one side be thicker, rougher, older? Why should the lava seas choose only one hemisphere? The leading explanation points back to that violent birth. When the moon formed, the near side cooled thinner, allowing lava to flood across it when impact struck. The far side, thicker and less forgiving, preserved its scars. To put it another way, one half was given a chance to heal through floods of molten rock. The other had to carry every wound forever. A cosmic unfairness, perhaps, but also a perfect geological time capsule. Unlike Earth, the moon never learned how to erase itself. Our planet is restless, reshaping through volcanoes, weather, oceans, and plate tectonics. Continents drift and collide, mountains rise and fall, and erosion scrubs away what was once towering. If you want to find evidence of Earth's early days, you'll struggle. It has been recycled. But the moon, without air or water, preserves its history like pressed flowers in a book. A crater formed billions of years ago remains etched with nearly the same sharpness today. It is a museum without janitors. Every exhibit left exactly where it fell. That permanence also makes the moon a place of haunting beauty. Imagine walking across its surface. No rustling leaves, no wind to move the dust, no weather to carry clouds across the sky. Shadows are sharp and permanent until you move your head. Footprints left by astronauts remain, likely for millions of years. And scattered among them is an unexpected collection of artifacts, tools, discarded modules, and even bags of astronaut waste. The moon has become both an archive of cosmic history and a junkyard of human progress. A strange mix, but one that shows our tendency to leave a trail wherever we go. Yet not all of the moon's surprises are ancient. Some happen every single month, whether we notice them or not, because the moon has something remarkable. It has a tail, not a symbolic one, not a poetic metaphor, but a real stream of particles flowing out behind it like the faint exhaust of a comet. The source is sodium atoms kicked up from the lunar surface by micrometeorite impacts and solar radiation. These atoms drift outward, forming a long invisible tail stretching millions of kilometers. Once a month, Earth passes through this stream. The moon's tail sweeps over us, brushing our planet with particles we cannot see. No sound, no glow, just a quiet crossing. Most people never hear of it, yet it has been happening for as long as the Earth-Moon system has existed. Our world, so solid beneath our feet, is touched each month by this ghostly exhale from its companion. If there's any humor in it, it is the thought that Earth, proud in its oceans and forests, is swept by something as delicate as lunar dust and never even notices. These subtle connections remind us that the moon is far more alive in its influence than its silence suggests. Even in its stillness, it changes Earth. Its pull on the oceans creates tides, rhythms that shape coastlines and govern entire ecosystems. Some species have tied their lives to the moon's cycle with exquisite precision. Along the Pacific coast, a small fish called the grunion waits for new and full moons to spawn. At high tide, under the silver glow, they ride the waves ashore, wriggling onto the sand to lay and fertilize eggs. Then, when the tides rise again 2 weeks later, the young emerge to return to the sea. Their lives are synchronized with a clock written in lunar gravity. The moon, then, is not just a passive lamp in the sky. It is a conductor of rhythms, a hidden partner in biology, and a cosmic archivist preserving the earliest scars of the solar system. And just when scientists thought they understood its barren nature, something else emerged to complicate the story. Water. For decades, the moon was assumed to be bone dry. Apollo samples seemed to confirm this. Dust and rocks brought home in the 1970s were tested and revealed little to no water. The moon, we were told, was a desert of dust and stone, stripped of moisture by its lack of atmosphere. The idea stuck so firmly that textbooks repeated it for generations. But science has a way of humbling certainty. In the early 21st century, new instruments detected hints of water, not in lakes or streams, but as ice in permanently shadowed craters, as molecules bound to minerals, and as vapor drifting in the exosphere. It was a quiet revolution. The dry moon had been hiding moisture all along. Some of it arrived via comets, icy messengers from the outer solar system. Some was created in place, as solar wind particles struck lunar soil and triggered chemical reactions. In those frozen craters near the poles, where sunlight never reaches, ice may have survived for billions of years. It is not the kind of water we drink from a stream, but it is there, fragile, scattered, but undeniable. The discovery reshaped how we think about the moon. It is no longer just a barren archive, but a place with resources. Future explorers may find water not only valuable for drinking, but also for splitting into hydrogen and oxygen, creating fuel. The very substance that once seemed absent might one day power voyages deeper into the solar system. There is gentle irony in that the moon, long considered lifeless and dry, may become the wellspring of exploration. And yet, the water comes with mysteries. On the far side, where Earth never shines, scientists found rust. Rust needs both oxygen and water, and the moon should provide neither. Yet samples show reddish minerals, hinting at strange chemistry. Perhaps Earth's magnetic field occasionally delivers oxygen to the lunar surface, combining with hydrogen from the solar wind and trapped moisture. Perhaps the very alignment of Earth and Moon makes possible a chemistry that should not exist. The details are still being untangled. But one truth is clear. The Moon refuses to behave like a simple, predictable rock. It is a place where shadows are eternal, where ice can last billions of years, and where chemical puzzles paint the ground with colors we do not expect. A place where stillness conceals motion and silence hides stories. A place that reminds us that the line between barren and alive is not as sharp as we once believed. Imagine stepping across the boundary between day and night on the moon. This line, called the Terminator, creeps slowly across the surface as the sun rises and sets over 2 long weeks. On one side, the land bakes in relentless sunlight, climbing to temperatures hotter than a desert at noon. On the other, darkness holds its grip, plunging the ground to deep cold. Between them is a fragile twilight zone, where shadows stretch endlessly, sharp and unblurred by air. This strange division, permanent and inescapable, makes the moon one of the harshest neighborhoods we know. For future explorers, that harshness is not just poetic, it is practical. Any structure placed on the surface will endure swings of nearly 300 degrees Celsius. Radiation streams unfiltered from the sun, micrometeorites, small but fast, pepper the surface with constant impacts. To build a home here is like pitching a tent in the middle of a firing range that alternates between furnace and freezer. And yet, there may be shelters already waiting. Lava tubes, vast hollow channels formed billions of years ago when molten rock flowed beneath cooling surfaces, may still exist beneath the moon's crust. Some of these tunnels could be wide enough to swallow skyscrapers, their roofs thick enough to shield against radiation and meteors. Hidden underground, temperatures might remain stable, and with the right equipment, humans could carve out habitats safe from the chaos above. It is one of those ironies space exploration loves to hand us. The most promising houses for tomorrow might be caves dug by eruptions billions of years in the past. We know these tubes exist because their skylights remain. Satellites have spotted pits and collapsed openings where sunlight plunges deep into darkness. They are invitations as much as geological scars. On Earth, caves often harbor secrets, paintings, bones, rivers of stone. On the moon, they may one day harbor life, not native, but brought by us. The very place that rang like a bell may yet echo with human footsteps beneath its surface. Still, even beneath rock, explorers will face another subtle hazard, moonquakes. Just as earthquakes shift the ground beneath cities, the moon trembles in its own ways. Some are caused by thermal expansion, when the surface heats or cools with the long day and night. Others come from deep within, triggered by gravitational interactions with Earth. But the most troubling are the shallow moonquakes, some strong enough to rattle structures with surprising force. During the Apollo years, seismometers recorded these quakes, some lasting for minutes, sending vibrations far and wide through the crust. Future bases, especially near the South Pole where ice may lie hidden, must take this into account. Imagine building a habitat in a region carefully chosen for its resources, only to discover it sits on ground prone to trembling. Modern seismometers, more sensitive than those Apollo left behind, will be essential tools in planning. They will not only help us predict danger, but also continue the strange symphony of echoes begun when the first ascent stage crashed into the moon. The South Pole has become the crown jewel of lunar ambition. Permanently shadowed craters may hold water ice, protected for billions of years from sunlight. In these dark vaults, temperatures sink so low that molecules cannot escape. Ice once melted and refined could provide drinking water, breathable oxygen, even rocket fuel. It is a frozen treasure chest, and nations are racing to unlock it. But shadow also means mystery. In those places, sunlight has not touched ground in eons. They are colder than Pluto, darker than the deepest night on Earth, and exploring them will require technology unlike anything used before. China's Chang'e 4 mission, launched in 2019, offered a taste of what exploration on hidden terrain can look like. It became the first spacecraft to land on the far side of the moon, a place invisible from Earth and shielded from radio contact. To communicate, China launched a relay satellite called Keiqiao, parked in a special orbit where it could peek around the lunar edge and pass messages back and forth. From that vantage point, a rover rolled across the far side's rugged surface, studying rocks and soil untouched by human or robotic wheels until then. The mission showed that persistence and clever engineering can turn the moon's obstacles into doorways. And with those new tools, the moon continued to reveal its strangeness. Instruments confirmed hydroxyls, molecules related to water, scattered in the soil. They even suggested the possibility of rust, a reddish blush where none should be possible. Rust is the product of oxygen, water, and iron. The moon has iron, but where would the other two come from? One idea is that Earth, in its generosity, sometimes donates oxygen through the solar wind, carried along magnetic fields during certain alignments, combined with hydrogen from space and trace amounts of lunar moisture. The conditions for rust may just barely appear. It is a chemistry set written across a barren plain, a puzzle as absurd as finding seashells in a desert. And while chemistry plays out in silence, another set of mysteries flickers in plain sight. For centuries, astronomers reported seeing lights on the moon, small flashes, glowing patches, mists, or sparks that seemed to appear and vanish in moments. These events came to be known as transient lunar phenomena, TLPs for short. Many dismissed them as illusions, tricks of Earth's atmosphere, or errors of the eye. After all, gazing at a distant world through turbulent air can make anything shimmer. But the Apollo era complicated that dismissal. Astronauts orbiting the moon, outside of Earth's distorting atmosphere, reported seeing them too, brief flashes, odd glows, things that didn't belong on a dead, airless surface. If trained astronauts floating in the vacuum of space witnessed the same events as amateur astronomers back home, then perhaps something real was happening. Lightning storms? Unlikely. Volcanism? The moon has been cold for billions of years. Electrostatic discharges? Maybe. The truth remains uncertain. Reminder that even in the age of satellites, the moon keeps a few flickers of mystery alive. It is tempting to laugh gently at the persistence of such phenomena. Humans, after all, have a knack for spotting faces in clouds and patterns in randomness. But when enough eyes, from backyard telescopes to orbiting command modules, record the same oddities, it suggests there may be small truths hiding in those flashes. The moon does not easily give up its secrets, but it teases just enough to keep us guessing. As we watch and measure, we continue to see the quiet power of the moon written on Earth itself. The tides, pulled by lunar gravity, do more than wash beaches. They churn nutrients along coasts, support migrations of fish, and shape the lives of countless species. Some corals release their eggs in synchrony with the full moon, painting reefs with floating clouds of life. Sea turtles time their journeys by the lunar light. Even humans, long before wristwatches and smartphones, measure time by its cycle, carving calendars in stone to track the waxing and waning glow. The moon's influence reaches so deeply into the roots of life that removing it from the equation feels like a thought experiment in alternate history. Without it, tides would weaken, coastal ecosystems might vanish, Earth's tilt could wander, and climates might swing wildly. In the grand ledger of conditions that made Earth hospitable, the moon holds a quiet but irreplaceable line. It has been less a rock in the sky than an architect of possibility. And all of this, quakes, tails, hidden ice, rust, flickers of light, reminds us that the moon is not finished surprising us. It is a fossil, a partner, a trickster, and a timekeeper. It is both barren and bountiful, silent and yet full of echoes. Every new discovery adds a layer to its personality, like meeting an old friend and realizing they've had secrets all along. If you were to stand on the moon's surface and gaze toward Earth, you would see something both familiar and alien. Our planet would hang in the sky the way the moon hangs for us, suspended, unmoving, always in the same place. Because just as we see only one face of the moon, so too would a lunar observer see only one face of Earth. The blue oceans, the swirling clouds, the green and brown of continents would shine as a permanent jewel in the sky. It would grow brighter and dimmer with the phases of Earthlight, but it would never set. For astronauts, that view was a revelation, a sight so powerful that words often fell short. To see home as a glowing ornament against the black backdrop of space was to feel both small and deeply connected. But what is remarkable is not only what the moon allows us to see, but what it allows us to remember. Earth, for all its vitality, is forgetful. Plate tectonics recycle its crust. Oceans wash away its lines. Winds erode mountains into grains. The surface is rewritten again and again, a palimpsest where old stories are erased to make room for new ones. The moon, in contrast, forgets nothing. It has no oceans, no winds, no moving plates. Its scars remain where they fell. Its craters freeze moments of history that would vanish on Earth. This difference means that while Earth offers life, the moon offers memory. Every crater is a page, every boulder a bookmark. Scientists sometimes joke that the moon is like a hoarder, refusing to throw anything away. But in that stubbornness lies value. By studying its untouched record, we glimpse the ancient history of the entire solar system. Impacts that battered the moon also battered Earth. But only on the moon do we see the evidence still sharp and clear. Among those scars, we have found more than beauty. Some regions reveal concentrations of mass buried beneath the surface, places where gravity is slightly stronger. These gravitational anomalies, called mascons, puzzled early spacecraft. Orbiters, meant to fly steady paths, suddenly dipped or swerved, as if tugged by invisible hands. For engineers, it was a nightmare. For geologists, it was a clue. Mascons may mark ancient lava seas, dense with iron-rich rock. They may reveal frozen remnants of heat flow mineral concentrations, or even volatile elements hidden deep underground. What once ruined flight paths may someday guide prospectors. The very quirks that confused early missions may turn out to be road signs pointing toward resources. That is the strange poetry of the moon. Its scars, its oddities, even its dangerous quirks can become gifts if we learn how to read them. Consider the reflectors left by Apollo astronauts. Small, simple panels designed to bounce back laser beams fired from Earth. More than 50 years later, those reflectors still return signals. Scientists send pulses of light that spread as they travel, widening to cover 2 kilometers across by the time they reach the moon. When they strike the reflector, only a few photons return, maybe one each second. It is faint work, requiring precision and patience, but the message comes back. With those signals, we measure the moon's distance to Earth with astonishing accuracy, down to millimeters. We have watched it drift slowly outward, year by year, the cosmic waltz unfolding at fingernail speed. This quiet drifting changes more than distance. It shapes eclipses, those brief spectacles when sun, moon, and Earth line up in perfect symmetry. Long ago, when the moon was closer, eclipses lasted longer, covering the sun completely. In the far future, as the moon recedes, it will appear too small. total eclipses will end, leaving only partial shadows and rings of fire. We live in a brief golden window of time when the geometry is just right. Out of billions of years, our lifetimes fall within the sliver where a perfect eclipse can occur. It is almost as though the universe enjoys small coincidences, placing beauty where it need not exist. The moon has also shaped human history in subtler ways. Its cycle gave rhythm to calendars long before mechanical clocks or digital screens. Months, after all, are moons. Farmers track planting and harvest by its phases. Fishermen read tides in its rise and fall. Poets and storytellers wove it into myth, sometimes as guardian, sometimes as trickster, always as presence. Cultures across the world preserve tales of a time before the moon, a sky without its silver glow. Such stories may be pure imagination, but they remind us of something important. The moon is not eternal. It had a beginning. There was a time when it was not there, and its arrival changed everything. Ancient memory or myth. Those tales point to a truth science agrees with. The moon is not a permanent fixture, but a chapter in Earth's story. That chapter is still being written. Today, multiple nations prepare missions not only to visit the moon, but to stay. NASA's Artemis program aims to return humans, this time to the South Pole. China, Russia, India, Japan, Europe, and others all have plans of their own. Commercial companies dream of mining, tourism, and permanent bases. For the first time in half a century, the moon is not simply a destination for flag and footprint. It is a target for settlement. And with settlement comes responsibility. The moon has already been touched by human messiness. Old landers, discarded modules, and forgotten tools still lie where they fell. Even bags of astronaut waste remain. The moon is pure in appearance but cluttered in detail, a museum of our journeys and our leftovers. As more missions arrive, questions of preservation grow louder. Should we protect historic sites like the Apollo landing zones? Should we treat lava tubes and craters as heritage? How do we balance exploration with respect for a place that cannot clean itself? In 2020, the Artemis Accords were introduced, a set of principles for responsible exploration. They call for sharing data, preserving historic landmarks, and avoiding conflict over resources. More than 40 nations have signed, though not all major players are included. It is a fragile beginning, an agreement written more in goodwill than in law, but it acknowledges what is at stake. The moon is not just a neighbor. It is a shared frontier. If we are to return, we must learn to live there without repeating the mistakes we made on Earth's oceans, forests, and skies. The thought of building on the moon often raises practical questions. How do you protect against radiation? How do you keep astronauts warm when the sun sets for 2 weeks? How do you grow food in dust that clings like glass and cuts like shards? Solutions range from covering habitats with regolith for insulation, to using lava tubes for shelter, to constructing greenhouses lit by artificial suns. Each idea is ambitious, but each is grounded in necessity. If we wish to stay, we must adapt, because the moon will not adapt for us. There is a certain humility in that. We often imagine space as an arena to conquer, but in reality, it is an environment to survive. The moon will not bend to our schedules or our comforts. Its quakes, its shadows, its silence, all remain indifferent to human presence. And yet, in that indifference lies possibility. A place so cold and harsh still holds ice, caves, and vantage points for telescopes free of Earth's haze. A place so scarred and ancient still offers clues to our own beginnings. To return to the moon is not to master it, but to learn from it. To walk among its shadows is to walk among history itself, to touch ground that has not changed in billions of years. And perhaps as new footprints join the old, we will realize that the moon is less an object to be used and more a partner to be understood. Step back for a moment and think of the moon not as a glowing disk above us, but as a body floating through space, an entire world of its own. From Earth it looks smooth, almost polished, but up close it is anything but. Its surface is uneven, scattered with jagged peaks, deep craters, and broad plains of ancient lava. Mountains rise higher than many of Earth's greatest ranges. Valleys stretch so wide they could swallow entire countries. What appears to the naked eye as a flat coin in the sky is in reality a vast landscape carved by violence and frozen in silence. Among its mountains stands Mons Huygens, one of the tallest peaks on the moon. It reaches 5.5 kilometers high, taller than Mount Rainier or Mount Whitney, dwarfing most mountains of the lower 48 states in America. Nearby, Mons Hadley rises even more dramatically from the plains, a stunning wall of stone near the site where Apollo 15 astronauts once landed. David Scott and James Irwin stood beneath that mountain in 1971, tiny figures against a backdrop so enormous it made their spacecraft look like a toy. Photographs from that mission captured the surreal scale. Human beings dwarfed by a peak that seemed to touch the edge of the stars. These mountains are not like Earth's, sculpted by tectonic uplift or slow erosion. They are the remnants of colossal impacts, the frozen waves left behind when the moon's crust was shaken to its core. They remind us that the moon's geography is a record of catastrophe. Where Earth hides its scars, the moon displays them openly, frozen for eternity. To walk there is to walk among echoes of cosmic violence, surrounded by cliffs and craters that have not changed for billions of years. And then there are the plains, the so-called seas, though they are seas only in name. The Maria, Latin for seas, are broad, dark regions formed when ancient impacts cracked the crust and allowed lava to spread across the surface. That lava cooled into basalt, a rock denser and darker than the highlands. Rich in iron and titanium, the basalt reflects less sunlight, which is why those regions appear as dark patches when we gaze up at the moon from Earth. Some of this lava cooled so quickly it formed glass, smooth and shiny, a detail so small and yet so telling. To look at the Maria is to see not calm waters, but the stillness of fire long extinguished. From those plains, astronauts left tools that continue to work. The retroreflectors, those small mirrored panels, still bounce back laser pulses fired from Earth. It is a delicate experiment. By the time the laser beam reaches the moon, it has spread to more than 2 kilometers wide. When it bounces back, only a handful of photons return, maybe 1 photon each second. Detecting that faint signal requires extraordinary patience, but it works. With it, scientists have tracked the moon's distance with millimeter precision. They have confirmed its slow drift outward, its orbit elongating with time, its gravitational dance stretching out over eons. That measurement may sound like trivia, but it carries weight. By knowing the moon's exact distance, we refine our models of Earth's rotation, of tides, of orbital mechanics. We confirm the subtle tug of lunar gravity on our planet's spin. Each photon that returns tells us a story of time, distance, and motion. It is a reminder that even the smallest objects can outlast almost everything else. Those reflectors have endured 50 years of micrometeorite impacts, extreme temperature swings, and constant radiation, and yet they still send back light. They are, in their way, symbols of endurance, small objects holding steady on a world that seems otherwise so alien. But endurance has limits, and even symbols can vanish. The moon itself has been a stage for disappearance. After the Apollo program ended, goodwill samples of moon rock were gifted to nations across the world. Many of those rocks have since gone missing. Some were stolen, some sold on black markets for millions, others simply misplaced in storage rooms or destroyed in accidents. Today, no one knows exactly how many remain. A curious fate for objects older than Earth's oldest mountains. Treasures of history treated like trinkets. It is almost comedic in a melancholy way that humanity could lose track of something as rare as pieces of another world. The moon has also been a stage for strange ideas. For centuries, people claimed its light was cold. Farmers once believed that moonlight falling on plants could stunt their growth. In the 19th century, some even performed experiments, placing thermometers in moonlight and swearing the temperature dropped. Of course, physics tells us otherwise. The moon reflects only about 12% of the sunlight it receives, and reflected light cannot cool. It adds a tiny bit of warmth, if anything. But in an era before modern science, light itself was mysterious. The very word lunatic comes from the belief that the moon influenced madness, moisture, and health. In truth, the moon's puldas influence water, but in the tides, not in our veins. Still, there is something charming in those old beliefs. They show how closely people watch the sky, how seriously they took its influence, even if their explanations were wrong. In modern times, science has replaced myth with measurement, but the moon remains strangely elusive. Take dust, for example. On Earth, dust is annoying but harmless. You brush it away and move on. On the moon, dust is one of the greatest hazards. It is sharp, jagged, and clingy, a product of billions of years without weather to smooth its edges. Astronauts who walked on the moon found the dust stuck to everything, suits, tools, visors, and smelled faintly like gunpowder when brought inside. Inhaled, it could damage lungs. Left unchecked, it could clog joints and ruin machinery. For future explorers, lunar dust is not an inconvenience, but an enemy, one that cannot be avoided, only managed. And yet, even in that dust lie secrets. Some of the water molecules discovered on the moon are bound within dust grains. Some of the strange flashes of light, the transient lunar phenomena, may be caused by dust stirred up by impacts or electrostatic charges. What we curse as nuisance may also hold clues to chemistry, history, and perhaps the resources needed for survival. On the moon, even annoyances demand respect. It is humbling to realize how much of the moon's strangeness is still hidden in plain sight. We thought it was dry, but it has water. We thought it was inert, but it quakes. We thought it was cold and lifeless. Yet it has a tail that brushes over Earth each month. The moon seems to enjoy reminding us that certainty is temporary, that the closer we look, the more surprises it has saved. In a way, the moon is like a patient teacher. It does not shout its lessons, but waits for us to notice. Each mission, each experiment, reveals one more detail of its character. The ringing of seismic waves, the discovery of lava tubes, the flicker of mysterious lights, the persistence of reflectors, all are small notes in a larger composition. And that composition is still unfinished. The moon, silent as it seems, has been speaking to us all along. We are only just beginning to learn its language. Close your eyes for a moment and picture the moon not as a glowing ornament in the night sky, but as a neighbor whose influence quietly extends into every part of life on Earth. It is easy to imagine it as distant and separate, but in truth, it is bound to us in ways far deeper than the light it reflects. Its gravity pulls on our oceans, shaping tides that flow like the pulse of a heartbeat across the planet. That pull is gentle, yet relentless. and in its rhythm entire ecosystems find their pace. Walk along a shoreline at dawn, and you might see the imprint of the moon written on the sand. Waves retreat farther than usual, leaving behind pools of stranded seaweed and crabs scrambling back to the water. Hours later, the tide will return, surging with renewed strength, reclaiming what it lost. This endless rise and fall is a dance choreographed by the moon's tug, with the sun joining in as a secondary partner. It is a ballet so reliable that sailors once steered by it and fishermen cast their nets in harmony with it. The moon, without a sound, has long been an unseen choreographer of life on Earth. Some creatures have woven this rhythm into their very survival. Along the Pacific coast, grunting fish wait for the highest spring tides, when the full or new moon pulls the ocean to its peak. Then, in the silvery glow, thousands of them wriggle ashore at once. The spectacle is brief but extraordinary. Fish laying eggs in wet sand, trusting that the next high tide, 2 weeks later, will release their offspring into the sea. It is life written in lunar ink. Coral reefs, too, use the moon as a clock. Some species release eggs and sperm simultaneously during full moons, creating synchronized blooms of life that stretch across entire oceans. Even insects, birds, and mammals show patterns linked to the lunar cycle, their migrations and breeding seasons guided by a clock far older than humanity. Humans, too, once lived more closely by that clock. Long before digital calendars, we divided time into months, moons. Farmers planted by its phases. Hunters tracked prey under its light. And storytellers wove myths about its cycles of growth and disappearance. To many cultures, the moon symbolized renewal, a reminder that darkness was not permanent, that light always returned. Even today, festivals across the world celebrate lunar cycles, from harvest moons to lunar New Years, each echoing that ancient reliance. Science, of course, explains the mechanics clearly. The moon's gravity pulls on Earth's oceans, creating bulges that move as the Earth rotates. Where the ocean is deep, tides are subtle. Where coastlines narrow, tides can tower. But beneath the equations lies something quieter. The sense that a world so distant can reach across space and shape the daily lives of crabs, corals, and children playing by the beach. It is a reminder that the moon is not simply overhead. It is inside our days and nights, a partner in the rhythms of the planet. Yet the moon's influence extends even further. It does not merely pull on water. It steadies Earth itself. Our planet spins at a tilt of about 23.5 degrees, an angle that gives us seasons. Without the moon, the tilt would wobble wildly under the gravitational tugs of Jupiter and other planets. Over thousands or millions of years, Earth might swing like a drunken top, its poles wandering, its climates lurching from ice ages to furnace heat. Life, under such unstable conditions, would struggle to gain a foothold. Complex ecosystems might never rise. Civilizations might never settle long enough to grow. The moon, small though it is, acts like a stabilizer. Its steady pull damps those chaotic swings, keeping Earth's tilt within a narrow range. That steadiness has allowed forests to grow, oceans to develop intricate food webs, and humans to build cities without fear that the sun would suddenly shift its course across the sky. It is strange to think that our existence may depend as much on the moon's quiet influence as on the sun's burning light. One gives energy, the other gives time. Together they create a stage where life can unfold. Long ago, however, the relationship was far more dramatic. Billions of years ago, the moon orbited much closer. It would have loomed enormous in the sky, lighting the night like a second sun. Its pull on the oceans was stronger, creating tides that surged across coastlines with violent force. As it drifted outward, the tide softened, Earth's rotation slowed, and days lengthened. What began as a chaotic embrace settled into a balanced partnership. The moon, once wild and domineering, became patient and steady, retreating inch by inch, but leaving Earth with the gift of stability. It is easy to forget that the moon is still moving away. Each year it recedes by nearly 4 centimeters, about the rate fingernails grow. Over billions of years, that small pace changes everything. In the far future, Earth will spin more slowly, days will stretch longer, tides will weaken further, and eclipses will disappear. The alignment we marvel at now, when the moon exactly covers the sun's disk, will no longer happen. The cosmic coincidence that dazzles us will be gone, leaving only partial shadows. We live in the brief sliver of history where such wonders are possible. Out of the planet's entire existence, we inhabit the rare moment when sun and moon match in size. That thought is both humbling and amusing. The universe does not choreograph beauty for our sake, yet we happen to witness it at the perfect time. It is as though we have stumbled into the theater in the middle of a performance, unaware of how rare the scene before us truly is. Billions of years before, no eclipses. Billions of years after, none again. Only now, only here, the moon in its quiet drift has given us not only stability, but also spectacle. Of course, the moon does not always behave in ways that inspire calm. It trembles, it quakes, it resists easy explanations. Shallow moonquakes recorded by Apollo instruments shook the ground hard enough that future explorers must worry about stability. Strange flashes of light, the transient lunar phenomena, remind us that the surface may be more active than we expect. Dust, sharp and sticky, challenges our machines and lungs alike, and its surface, scarred and unchanging, reminds us that space is not forgiving. For all its beauty, the moon is also a test. Yet perhaps that is what makes it so compelling, is both ally and obstacle, guardian and hazard. It steadies Earth, yet shakes itself. It preserves history, yet complicates exploration. It is barren, yet holds water. It is still, yet flickers with mystery. The contradictions pile up until the moon feels less like an object and more like a character, a silent partner in Earth's story whose role keeps evolving. And as we prepare to return, that partnership will be tested again. The moon is no longer just a subject of wonder. It is a target of ambition. Artemis missions, Chinese rovers, private landers, all look to claim a place on its surface. Lava tubes may become homes, ice may become fuel, and its highlands may host observatories peering farther into the universe than ever before. The moon may become not only our memory, but our gateway. What it asks of us is humility. To survive there, we must adapt to its silence, respect its scars, and learn to live with its dust and quakes. To thrive, we must see it not as an enemy, but as a partner, one that has already given us stability, rhythm, and time. In return, we may find in its shadows the resources to take our next steps beyond Earth. And perhaps as future explorers look back from lunar soil and see Earth shining steadily in the sky, they will feel what the Apollo astronauts felt: awe, fragility, and a sense that the moon is not what we thought. It is stranger, harsher, and more generous all at once. A neighbor that has shaped our past and may yet shape our future. If you were to walk across the lunar surface, your boots pressing into fine gray dust, you might be surprised by how stubborn that dust becomes. It clings to everything, fabric, glass, metal, as though magnetized, though it is not. The reason lies in its history. On Earth, winds and rains grind rock into smooth grains of sand. But on the moon, with no atmosphere and no weather, the grinding comes only from impacts. Micrometeorites slam into the surface at thousands of kilometers per hour, crushing rock into powder and fusing particles into jagged shards. Each grain of lunar soil is sharp-edged, abrasive, and electrostatically charged by solar radiation. To step on it is to step on billions of tiny knives and magnets at once. The Apollo astronauts learned this the hard way. Their suits and visors came back scratched, their joints clogged, their lungs irritated by dust tracked into the lunar modules. Some reported the dust smelled faintly like gunpowder once it was disturbed, a strange reminder that even silence can have a scent. For future explorers, dust is one of the greatest hazards. It can foul machinery, damage lungs, and slowly destroy anything left exposed. It is ironic, almost comedic, that in a place where the greatest dangers seem to be radiation and vacuum, one of the most stubborn enemies is dust. And yet, in those particles lie secrets. Mixed within the dust are traces of water molecules, clinging to grains through chemical bonds. These molecules are not enough to form puddles or streams, but they reveal a hidden cycle. The moon, once thought bone dry, breathes water in whispers, frozen in shadowed craters bound in minerals, drifting in a ghostly exosphere. It is a water cycle stripped to its barest form, molecules moving quietly from place to place, waiting in the cold until disturbed. This discovery was a shock. For decades, textbooks declared the moon arid. Apollo samples seemed to support that view. When tested in the 1970s, the rocks appeared dry. But decades later, with more advanced tools, scientists found hints of water hidden inside those same rocks, locked away in tiny glass beads formed by volcanic eruptions. It was there all along, invisible to the instruments of the time. The moon, like a magician, had hidden its trick in plain sight. Even stranger, water seems to be unevenly distributed. In the deep shadows of polar craters, ice may lie undisturbed for billions of years, protected from sunlight by walls so steep that not a single ray has touched them since their formation. These craters are colder than Pluto, colder than the most distant reaches of the outer solar system, despite being only a few 100,000 kilometers away. They are vaults of ice, blacker than night, colder than deep space, holding clues to comets' solar wind, and perhaps even the ingredients of life. For explorers, these icy craters are treasure chests. Water can be melted for drinking, split into hydrogen and oxygen for fuel, or stored for long-term habitation. In space, water is survival. To find it so close at hand changes everything. The moon shifts from barren rock to a stepping stone, a refueling station for journeys deeper into the solar system. What was once only a lantern in the sky becomes a wellspring of possibility. Still, questions remain. Why does rust appear on the moon when oxygen and liquid water are absent? Why do some regions hold more hydroxyls than others? Why does the far side, shielded from Earth's influence, show stronger signs of rust than the near side? These puzzles remind us that chemistry can be trickier than intuition. Perhaps Earth's magnetic field delivers oxygen through streams of solar wind. Perhaps micrometeorites stir reactions in just the right places. Or perhaps, as with so many mysteries, the answer has not yet been found. The moon seems to enjoy confounding us. It tempts us with simple stories, a dry rock, a silent fossil, a lifeless companion, only to reveal hidden complexities. Each discovery peels back a layer, only to show another beneath. In this way, the moon feels less like an object to be cataloged and more like a story that refuses to end. Consider, for example, the strange flashes of light known as transient lunar phenomena. For centuries, observers reported seeing glows, sparks, or mists on the moon's surface, usually lasting just seconds or minutes. Most scientists dismissed them as illusions caused by Earth's atmosphere. But Apollo astronauts, orbiting the moon without any atmosphere between them and the surface, reported the same flashes. Something real was happening, though no one could say exactly what. Volcanic activity? Electrostatic discharges? Outgassing of trapped gases? The truth remains elusive. Even today, occasional flashes are caught on modern cameras, teasing us with the possibility that the moon is not as inert as we think. There is a gentle humor in this persistence of mystery. For all our technology, for all our satellites and sensors, the moon still plays tricks on us, as if reminding us not to become too confident. It has been under our gaze for all of human history, and yet it continues to hide surprises in plain sight. Perhaps that is why it remains such a powerful symbol. We think we know it, but we do not. We trust its presence, but we cannot explain all its behaviors. It is, in the end, the perfect companion for a species that is itself curious and restless, always learning, never finished. The moon's surprises extend even to gravity. Its surface is not evenly balanced. Some regions tug more strongly than others, thanks to dense masses buried beneath. These gravitational quirks once ruined spacecraft trajectories, pulling probes off course, causing missions to fail. But in those irregularities lies information. They are signs of ancient lava flows, mineral deposits, or frozen remnants of heat long gone. What once caused confusion may someday guide miners or explorers searching for resources. The moon's uneven gravity is both obstacle and map, frustrating but also informative. When we look up at the moon, we see only its face, the same markings gazing down night after night. But beneath those markings lies a deeper truth. It is not smooth, not balanced, not uniform. It is lumpy, scarred, tilted, and off-center. Its crust is thicker on the far side, its core offset from the middle, its shape slightly elongated. It is a world of asymmetry, a place that looks serene but hides imbalance. There is something almost comforting in that imperfection, a reminder that even celestial bodies do not need to be symmetrical to be beautiful. As humanity prepares to return, we carry both ambition and caution. We dream of bases in lava tubes, of harvesting ice from craters, of building observatories free from Earth's haze. But we also know the risks. Dust that cuts like glass, quakes that rattle the ground, radiation that seeps silently into skin and metal. To live on the moon will not be easy. It will test patience, endurance, and humility. And perhaps that is why it calls to us so strongly. Not because it is easy, but because it is difficult in ways that reveal who we are. The moon is a paradox. It is barren yet resourceful, silent yet ringing, still yet trembling, familiar yet unknown. It is close enough to reach, but strange enough to challenge us. It is a reminder that mystery does not always lie in distant galaxies. It can hang just overhead, in a face we have watched for millennia without fully understanding. And so the moon waits. Its dust, its ice, its scars, its hidden chemistry, all are there, patient and indifferent, until we are ready to learn. The ringing that began in 1969 still echoes, in a way, not in seismic waves, but in our curiosity. The moon has knocked from the inside, and we are still listening. Stand beneath the dark sky, and you may feel that the moon has always been there, unchanging, eternal, as steady as the stars around it. Yet the truth is stranger. The moon is not eternal. It had a beginning, and with that beginning came profound consequences. Without it, Earth itself might be unrecognizable. There was a time billions of years ago when no moon circled our world. Ancient myths from cultures far apart, Greek, African, Native American, speak of a sky before the moon, an era when nights were darker and different. Whether these stories are echoes of deep memory or simply the imagination of storytellers, they remind us of something science confirms. The moon was born from an event, not given from the start. A violent collision, a great merging of worlds, left Earth with its companion, and from that moment onward, nothing was the same. The young moon orbited much closer than today. It loomed massive in the sky, perhaps 20 times larger than we see it now. Its glow would have turned night into day, pulling tides so enormous that they surged hundreds of kilometers inland. Those tides may have shaped the earliest life, stirring coastal pools, mixing nutrients, and creating conditions for chemistry to dance toward biology. Without the moon's closeness in those early days, the fragile spark of life might have struggled to find its rhythm. As the moon drifted outward, Earth's days lengthened. At first, a day on Earth may have lasted only 5 or 6 hours. With the moon's pull slowing the rotation, days stretched longer, stabilizing climates, pacing the planet in a gentler rhythm. What began as chaos settled into balance. The moon's slow retreat carved out the days and nights we now take for granted. That stability matters more than we often realize. Earth's tilt of 23.5 degrees gives us seasons. Without the moon to hold that tilt steady, gravitational nudges from Jupiter or other planets could have caused wild variations. Imagine Earth's axis wandering by tens of degrees, poles drifting, climate swinging, forests dying and regrowing in endless cycles. Complex life might never have had the time to evolve. Civilizations might never have had the chance to flourish. In its quiet orbit, the moon brought Earth the most precious gift of all, time. Today, the moon continues its work, steady and unnoticed. It lengthens days by fractions of seconds per century, pulls tides that feed ecosystems, and shapes eclipses that thrill and humble us. It reminds us that stability itself can be an act of creation. Life on Earth owes as much to the moon's patience as to the sun's fire, and yet for all its patience, the moon holds mysteries that resist easy answers. One of the strangest is its exosphere, the whisper-thin layer of particles drifting above the surface. Technically, the moon has no atmosphere, but it does have this tenuous halo of atoms, helium from the solar wind, sodium from the soil, even oxygen stripped from Earth's magnetic tail during certain alignments. It is invisible to the eye, too sparse to breathe, but it is there. And once a month, as Earth passes through the moon's sodium tail, our planet itself is brushed by that invisible breath. There is something poetic about that. Earth, with all its air and oceans, still receives a faint exhale from its smaller companion. It is a reminder that boundaries in space are not as sharp as we imagine. Worlds touch each other in ways we cannot see. Our skies are threaded with connections, quiet exchanges of atoms and light. The moon, even in silence, participates in Earth's atmosphere, just as Earth participates in the moon's chemistry. This exchange may help explain another puzzle. Rust on the moon. Rust requires oxygen, and oxygen requires air or water, neither of which the moon should have. Yet reddish patches have been found, particularly on the far side. One explanation is that Earth provides the missing ingredient. During certain times of the month, Earth's magnetic field stretches far enough to carry oxygen atoms from our own atmosphere to the moon. combined with solar wind hydrogen and trace water. Conditions for rust appear in places that should never allow it. The moon, in this sense, bears the fingerprints of Earth's breath. Its very surface holds evidence of our shared relationship. The moon is also a stage for light and shadow unlike anywhere else. Because it has no air to scatter sunlight, shadows are black and absolute. Step into shade, and you are hidden in darkness colder than the poles of Pluto. Step into light, and you are baked by unfiltered solar radiation. In some craters, the contrast creates regions of perpetual light and perpetual darkness. Eternal day beside eternal night. At the poles, peaks catch constant sunlight while nearby pits remain frozen in shadow for billions of years. These extremes make the lunar poles some of the most pristine and alien environments in the solar system. Within those shadows may lie the future of exploration. Permanently dark craters colder than outer planets hold ice deposits that could sustain human outposts. Permanently lit peaks, called peaks of eternal light, could provide constant solar power. Together they offer both resources and energy, the essentials of habitation. What once seemed like the most hostile corners of the moon may prove to be the most valuable. Still, building there will not be easy. Extreme temperatures, radiation, dust, and quakes all demand solutions. Engineers imagine habitats covered with regolith for insulation, or carved into lava tubes for protection. Some imagine greenhouses lit by mirrors or artificial suns, plants growing under domes, as lunar soil is refined to support life. Others propose robotic miners harvesting ice and metals, while humans live in sheltered bases. Each idea is ambitious, but all are rooted in necessity. If we are to stay, we must adapt. The moon will not adapt for us. Even in its dangers, the moon offers perspective. Its silence is not emptiness, but endurance. Its scars are not ruin, but memory. Its quakes are not threats alone, but clues. Every challenge is also a lesson in resilience. Humanity has often dreamed of reaching other worlds. The moon, so close yet so harsh, is a perfect testing ground. If we can live there, we can live elsewhere. If we can endure its dust, its darkness, and its silence, we will have proven something not only about technology, but about ourselves. And so the moon becomes both mirror and gateway. A mirror because it reflects our own persistence, our tendency to leave footprints and tools and questions wherever we go. A gateway because it offers the resources and the practice needed to step beyond Earth. It is not just a neighbor to be admired, but a threshold to be crossed. When the first Apollo astronauts walked its surface, they left behind more than footprints. They left instruments, reflectors, flags, even small personal items. They also left waste, bags of it, because even in exploration, humanity brings its untidiness. Today, those items remain. The moon holds both the grandeur of cosmic history and the trivia of human presence. It is at once a museum and a junkyard, a place where billion-year-old craters sit beside broken tools from 1969. And somehow, that combination feels honest. For all our aspirations, we are still messy creatures, learning as we go. The moon does not judge. It simply preserves. Every object left there, every footprint, every experiment, remains where it was placed, waiting for the next visitor to stumble across it. It is a record not only of geology, but of humanity itself, frozen in time. And perhaps that is part of its lesson, that nothing we do is erased easily. Our actions endure, sometimes far longer than we imagine. Look up tonight, and you will see it glowing, a pale reminder that history is still above us. The moon is not what we thought, and it never was. It is harsher, stranger, more fragile, and more generous all at once. And as it continues its patient orbit, drifting ever farther away, it carries with it the echoes of our past and the promise of our future. If you look at the moon from Earth, it appears serene, as if carved in stillness. Yet beneath that quiet face, the ground is restless. For though the moon has no atmosphere, no storms, and no oceans, it does have quakes, moonquakes. When the Apollo astronauts placed seismometers on its surface, they recorded thousands of them. Some were shallow and strong, lasting for minutes. Others were deep and faint, stirred by the constant tug of Earth's gravity. Still others were thermal, caused by the crust expanding and contracting as it shifted between scorching day and freezing night. Unlike earthquakes, which rattle, boom, and fade, moonquakes often rang like slow, drawn-out echoes, reverberating through the brittle crust as though the world itself were a bell refusing to stop vibrating. For scientists, these quakes were more than curiosities. They revealed what the moon is made of. Seismic waves behave differently in different materials. By watching how they travel, bounce, and fade, researchers sketched the moon's interior. A crust thicker than Earth's, a mantle that is dry and rigid, and a small core far less active than our own. The moon is not hollow, as conspiracy theories like to whisper, but it is fractured, stiff, and strange. Its very silence is a clue. For future explorers, however, quakes are more than science. They are hazards. Imagine building a base near the lunar South Pole, drawn by the promise of ice hidden in shadowed craters, only to find the ground trembling beneath your habitat. The vibrations may not topple mountains, but they could crack structures or loosen machinery. Planning for a lunar presence means planning for a world that still shakes. Gently but persistently, the South Pole has become the focus of dreams. Its permanently shadowed craters may hold billions of tons of ice, frozen for eons, untouched by sunlight. These dark vaults are colder than the outer planets, yet only 3 days travel away. To explore them, we will need machines that can see in total darkness, endure extreme cold, and dig where no light has touched since before life began. The rewards, however, are immense. Water can sustain humans, fuel rockets, and create oxygen. In a universe where survival depends on resources, ice is more valuable than gold. Nearby, there are peaks of eternal light, mountains and ridges that catch the sun's rays almost all year round. In a world of long days and nights, these are rare places where solar panels could work nearly continuously. Shadow and light, ice and energy. Together they form the recipe for settlement. The moon in its extremes provides what we need, but never without challenge. It is not only quakes and craters that shape the future. The moon's dust, so easily overlooked, is one of the greatest obstacles. Each grain is razor-sharp, clinging to suits, scratching visors, and damaging lungs. Apollo astronauts wrestled with it, coughing when particles entered their modules. Lunar dust is so fine it seeps into every joint and hinge. It may seem laughable that dust could rival radiation and vacuum as a threat, but on the moon, the smallest things are often the most stubborn. For long-term habitation, managing dust will be as important as managing oxygen. Even in its dust, though, the moon surprises us. Those jagged grains hold water molecules bound by chemistry. They capture particles from the solar wind, record the history of radiation, and may even preserve clues about comets and asteroids that once struck. To study dust is to study time itself. The moon, barren as it looks, is covered in archives, tiny and convenient, but invaluable. There is another archive, too, hidden in its strange flashes of light. For centuries, astronomers claimed to see sudden bursts on the lunar surface, mists, sparks, or glowing patches, known as transient lunar phenomena. These events were long dismissed as illusions caused by Earth's atmosphere. But then came Apollo, astronauts orbiting the moon far above our distorting air, reported seeing the same thing. Brief flashes, mysterious glows. If it wasn't the atmosphere, then it was something else. Electrostatic discharges, perhaps, or small meteoroid impacts lighting the surface for an instant. Whatever the cause, the moon occasionally blinks, reminding us that it is not entirely asleep. These mysteries are not isolated curiosities. They fit into a larger story. The moon is still active, just in ways subtle and alien. It does not roar with volcanoes or storms, but it trembles, glows, and exhales faint particles. Its activity is quiet, but it is activity nonetheless. To call it dead is to misunderstand. It is a world alive in its own restrained way. And then there is the far side. For all of human history, it was hidden, never turning toward Earth. Only when spacecraft circled the moon did we see it. What they revealed was startling. Unlike the near side, with its broad, dark maria, the far side is rugged, mountainous, and densely cratered. It is thicker, heavier, older in appearance. Why one hemisphere should be so different remains a puzzle. Perhaps the near side's thinner crust allowed lava to flow and smooth it. Perhaps impacts were distributed unevenly. Whatever the cause, the moon's two faces are as distinct as night and day. In 2019, China's Chang'e 4 mission became the first to land there, a feat that required placing a relay satellite in lunar orbit to maintain communication. The rover that rolled onto the far side entered a place untouched by human or robotic hands before. The achievement was more than symbolic. The far side, shielded from Earth's radio noise, is an ideal place for telescopes, listening to the faint whispers of the universe without interference. What was once hidden may become the perfect window to the stars. This duality, near side familiar, far side alien, shapes our relationship with the moon. We told myths about the face we saw, but we had no stories for the one we did not. Our imagination was guided by a half-truth, a biased view. Even now, despite satellites and missions, that asymmetry lingers. The moon reminds us that what we see is never the whole picture. Every familiar surface may hide another side, waiting for patience and technology to reveal it. As humanity returns, this lesson will grow sharper. Nations are racing to claim footholds. NASA with Artemis, China with its South Pole ambitions, Russia, India, Japan, Europe, and private companies joining in. The moon is no longer just a goal of pride. It is a resource, a laboratory, a stepping stone. But with opportunity comes tension. Who will mine the ice? Who will claim the peaks of light? Who will preserve the historic sites of Apollo? And who will treat them as relics in the way? The moon has been patient, but humanity is rarely so. Already, agreements like the Artemis Accords attempt to set principles for cooperation, asking nations to share data, preserve heritage, and avoid conflict. Yet not every major player has signed. The moon, once a symbol of unity and exploration, may yet become an arena of competition. It is both inspiring and sobering to realize that our next chapter there will reveal as much about human nature as about lunar geology. Still, when astronauts return, when rovers crawl into shadowed craters, when telescopes unfold on the far side, the moon will continue to surprise. It has done so for millennia. It will do so again. Its quakes, its dust, its asymmetry, its hidden ice, All are reminders that even the most familiar object in the sky is not truly known. The moon is not what we think. It is stranger, harder, and more necessary than we imagined. If you were to stand at the edge of a lunar crater at sunrise, you would witness a scene unlike any dawn on Earth. The sun would creep slowly upward, its light unbroken by air or clouds. Shadows would stretch razor-sharp, unsoftened by haze. Rocks would glow with a stark brilliance, every edge clear, every surface exposed. There would be no blue, no gradual brightening of sky, only blackness giving way to blinding white. The contrast would be so extreme that your eyes would struggle to adjust. On the moon, light and dark are absolute, as if the world is painted in only two colors. These extremes create environments found nowhere else. At the poles, there are craters so deep and steep that sunlight has not touched them for billions of years. Inside, temperatures plunge to levels colder than Pluto, trapping ice in permanent darkness. Just a ridge away, there are peaks that bask in near-constant sunlight, peaks of eternal light, where solar panels could gather energy without pause. Light and shadow, side by side, both eternal in their own way. It is a geography so alien and yet so close, waiting just above our heads. For scientists, these regions are treasures. Ice and shadow craters is a time capsule of the solar system, holding water that may have arrived from comets or asteroids eons ago. Studying it could reveal where Earth's own water came from. For explorers, the ice is survival. Drinking water, breathable oxygen, and rocket fuel waiting to be unlocked. Combine it with the sunlight on nearby ridges, and you have the ingredients for a permanent base. It is as if the moon, indifferent though it is, offers us both challenge and opportunity in the same breath. But the moon's gifts are not given easily. The same ice that promises survival is locked away in darkness so deep that no solar-powered rover can survive without assistance. Batteries freeze, instruments fail, and metal becomes brittle. To explore those craters, we must build machines tougher than any we have sent before, machines that can crawl in shadow, powered by nuclear hearts or by tethers to solar collectors above. Each step into those depths will be a test of ingenuity. The challenges extend beyond shadow. Radiation streams constantly across the lunar surface. On Earth, our magnetic field and atmosphere shield us. On the moon, there is no such protection. Micrometeorites strike at high speeds, unburned by air. Temperature swings by nearly 300 degrees Celsius between day and night. Any base, any habitat, must endure these extremes. Some solutions may lie in lava tubes, ancient caves formed by flowing magma, large enough to shelter skyscrapers. Covered by meters of rock, they would protect against radiation and impacts, offering stable temperatures. What nature carved by fire, humanity may one day use for refuge. Even with shelter, we face dust. The fine, jagged regolith clings to everything, scratching visors, clogging joints, irritating lungs. Apollo astronauts wrestled with it after only a few days. Imagine years. Engineers now study ways to repel dust with electric fields, magnetic coatings, or airlocks that shake it off before entering habitats. On the moon, survival will mean learning to live with dust, to respect its persistence. It is not dramatic like radiation or quakes, but it may prove the hardest enemy. And then there are the quakes. The moon trembles with shallow and deep moonquakes, some lasting 10 minutes or more. Imagine your home vibrating, not for seconds, but for hours. Future architects will need to build with flexibility, anchoring structures against shaking ground. In a world that looks frozen, movement is always possible. Yet for every obstacle, the moon offers perspective. Its scars remind us of cosmic history, impacts that Earth experienced too, but erased with time. Its ice whispers of water's journey through space. Its dust records radiation from across billions of years. Even its quakes tell us about its dry, fractured interior. The moon is not just a destination. It is a library of the solar system, open to anyone who can read its pages. It is also, curiously, a stage for human character. When Apollo astronauts stood on its surface, they looked back at Earth and saw it whole for the first time. A blue and white sphere rising above the gray horizon. Small, fragile, unified. That image, Earthrise, changed the way many people thought about our planet. Boundaries vanished. Nations shrank. The whole world became a single, shimmering island in the void. The moon gave us perspective not by what it showed us of itself, but by what it revealed of home. Today, new explorers will carry that same opportunity. As they walk in shadows no one has seen, as they look up at Earth steady in their sky, they will be reminded again of our fragility and our possibility. The moon may test us, but it also reflects us. It preserves our footprints, our discarded tools, even our mistakes. It does not erase, it remembers. In its silence, it holds a record of who we are. This permanence has a quiet irony. On Earth, our greatest works crumble with time. Cities fall, statues erode, books decay. But on the moon, a footprint lasts for millions of years. A bag of tools remains where it was dropped. A flag, though bleached by sunlight, still stands in dust. The moon, in its stillness, may preserve the story of humanity long after Earth has reshaped itself. In a sense, the moon may be our most enduring monument, not built intentionally, but left accidentally. And that may be the most humbling truth of all. For all our pride, for all our ambition, what endures longest may be the quiet traces left on a silent world. The moon, patient and indifferent, will keep them safe. Our machines will rust. Our nations will change. But the dust will remember. Look up tonight, and the moon will be there glowing softly, carrying secrets in its shadows and history in its dust. It is not what we thought. It is stranger, harsher, more generous, and more necessary than we imagined. It is a partner, a mirror, a record, and perhaps a promise that even in silence, even in stillness, there is more to discover. When we look at the moon, we often imagine silence, a place without air, without sound, without movement. But silence is not the same as emptiness. The moon has its own quiet phenomena, subtle forces that stretch invisibly into space. One of the strangest is its tail. Yes, the moon has a tail, not metaphorical, not poetic, but a real stream of particles flowing behind it like the faint trail of a comet. The source lies in sodium atoms, knocked from the lunar surface by micrometeorite impacts and solar radiation. These atoms drift outward, forming a cloud that stretches for millions of kilometers. Once a month, as the moon passes between Earth and the sun, our planet moves through this stream. Unseen, unheard, unnoticed, we are brushed by the moon's tail. It is a humbling thought. Earth, with its oceans, forests, and storms, is touched monthly by a dust of atoms from a world we think of as barren. We walk through the moon's invisible exhale without ever realizing it. Most people have never heard of this phenomenon, though it has been happening for billions of years. The moon, so steady above us, still leaves fingerprints on Earth's space. This quiet connection joins others. The moon shapes tides, stabilizes Earth's tilt, and governs cycles of life. It also lends its atoms to us and receives atoms from us. When Earth's magnetic field stretches outward, it carries oxygen particles into space. Some of those find their way to the moon, where they interact with the soil, creating unexpected chemistry, perhaps even helping explain the patches of rust. The two worlds are bound together not just by gravity, but by a subtle exchange of matter. We breathe into one another without noticing. For ancient cultures, these unseen connections were imagined as magic. The moon was credited with influence over crops, health, and even madness. The very word lunatic comes from the belief that lunar phases shaped human minds. Aristotle thought celestial bodies influenced nature energetically, not just gravitationally. Farmers watched its cycles to time planting. Sailors trusted its light on the sea. Myths turned the moon into gods, goddesses, rabbits, lions, or eyes of the heavens. Each culture projected its imagination onto the same pale face. The near side, with its familiar markings, became a canvas for human thought. Yet half the moon remained unseen. The far side, hidden by tidal lock, played no role in mythology. It was unknown, invisible, a blank space in the collective imagination. Only in 1959 did a Soviet probe send back the first photographs, revealing a landscape utterly different from what we expected. Dense craters, jagged mountains, no broad Maria like the near side. It was a reminder that our stories had been written on a partial truth. We dreamed of the moon, but only of half of it. That asymmetry shaped science as well as myth. Astronomers pointed telescopes only at the familiar face. Early landing sites were chosen based on visible features. The far side was ignored not by choice, but by necessity. Even now, despite satellites, our emotional bond remains tilted. We know the far side exists, but we feel attached to the face we grew up with. The moon, like companion we only ever see from one angle, is both familiar and mysterious. This duality, known and unknown, is part of its enduring power. The moon gives us certainty. It rises, it sets, it cycles with regularity. But it also hides, half its body unseen, its chemistry surprising us, its history written in scars we cannot fully read. It is both steady and elusive, a paradox that matches our own nature as curious beings who crave both stability and mystery. Modern missions have begun to tilt that balance. When China's Chang'e 4 rover rolled on the far side in 2019, it entered a place no human or robot had touched before. To do so, engineers had to solve a problem: communication. The far side is permanently shielded from Earth's radio signals. To stay in touch, they placed a satellite, Keiqiao, in a special orbit that allowed it to relay messages. With that, the rover began exploring craters that had been invisible for all of human history. In one step, the hidden half became tangible. But exploration comes with reminders. The far side may be a scientific treasure, perfect for radio telescopes shielded from Earth's noise. But it is also a place of challenges. Steep terrain, communication delays, and the same hazards of dust and radiation all demand caution. Each mission uncovers new data, yet also new questions. Why is the crust thicker on that side? Why so few Maria? Why the difference at all? The moon, even when revealed, refuses to be fully explained. And perhaps that is what makes it so compelling. We are not drawn only to what we know, but to what eludes us. The moon gives us both: a face so familiar we feel we own it, and a side so strange it humbles us. It is comfort and challenge in the same sphere. In this way, the moon also reflects something deeper about humanity. We project meaning onto it, yet it resists our projections. We seek to master it, yet it continues to surprise us. We treat it as stable, yet it moves away each year. We imagine it as empty, yet it hides water, dust, and rust. The moon is not just a rock. It is a reminder that the universe is always more complicated than our stories. Look closely, and you may see the humor in this. We have spent millennia writing myths about the moon controlling madness, crops, and weather. Yet when Apollo astronauts returned with samples, those rocks seemed bone-dry, lifeless. Only decades later did we realize water was hidden inside. For a world we thought we knew so well, it has repeatedly turned our confidence into irony. The moon smiles quietly, not in light, but in its habit of proving us wrong. As we return building plans for bases and telescopes, we must remember this. The moon will not be simple. It will not be conquered with ease. It will demand respect, patience, and adaptability. But in exchange, it offers perspective, history, and perhaps a path to the stars. It has already given us stability, tides, and time. Perhaps now it will give us a doorway. Yet even if we never built bases, even if no one ever mined its ice, the moon would still matter. It has shaped Earth's history for billions of years. It steadies our tilt, calms our climate, lengthens our days. It gave our ancestors light in the night, rhythm in the months, and wonder in their stories. It gave modern science a laboratory of extremes. And it gave all of us at least once the image of Earth rising above its horizon, a reminder that our home is fragile, beautiful, and shared. The moon is not what we think. It never was. It is stranger, harsher, more generous, and more necessary than we imagined. And perhaps that is why we cannot stop looking up. Imagine walking along the edge of a lunar plain. The horizon curving so near that it feels as though the world is smaller than it should be. Above you, Earth shines, suspended like a jewel. Beneath your feet, the ground is silent, yet everything about it is the product of violence. Every crater, every ridge, every scattering of boulders tells the story of collisions. Where Earth renews itself through tectonics and erosion, the moon preserves its wounds. To walk across it is to walk through time itself, unchanged for billions of years. Those scars, however, are more than relics. They are maps. Beneath some lie vast concentrations of mass, invisible but detectable. Early spacecraft discovered them by accident. As probes orbited the moon, they dipped and swayed, pulled unexpectedly by regions of stronger gravity. These anomalies, mascons, short for mass concentrations, were both dangerous and mysterious. Engineers cursed them for ruining trajectories, but geologists smiled. Mascons told of ancient seas of lava, dense with iron and titanium, filling great basins after colossal impacts. They recorded not just destruction, but recovery, how the moon healed itself with floods of molten rock. Even now, mascons remain useful. They hint at mineral riches, ancient heat flow, or even volatiles trapped deep beneath the crust. What once pulled spacecraft off course may one day guide prospectors toward resources. It is one of the moon's many paradoxes. Its flaws are clues, its quirks are gifts. The lava plains themselves, the Maria, are reminders of this. To the eye, they appear as dark patches forming faces and figures, the so-called man in the moon. To the geologist, they are seas of frozen fire, basalt heavier and darker than the highlands. Some regions are glassy, cooled so quickly that crystals never formed. Others are riddled with iron, giving them their dark hue. Each patch is a record of a time when the moon was not still, when its insides erupted across its face. What we now see as calm dark shapes were once oceans of molten rock, glowing red beneath a younger sky. In these planes, astronauts left tools that continue to work. The retroreflectors, those simple mirrored panels placed on the surface more than half a century ago, still return light. Scientists fire lasers at them from Earth. The beams spread to kilometers across by the time they arrive, and only a few photons bounce back, perhaps one every second. Yet even that is enough. By measuring the return time, we know the moon's distance with millimeter precision. We have watched it drift, slow and steady, away from us. Each photon is a message, silent and ancient, telling us about a dance billions of years in motion. The drift is small, about 4 centimeters per year, the pace of fingernail growth. But over time, it reshapes our relationship. When the moon was closer, it pulled tides higher, made eclipses last longer, and filled the night sky like a second sun. In the far future, when it drifts farther still, total eclipses will cease. The sun will outgrow it in our sky, leaving only partial shadows and glowing rings. We live in a rare window when geometry creates perfection, when the moon can cover the sun exactly. Out of billions of years, we happen to exist in the sliver when eclipses are total. The odds are staggering, the coincidence almost comical. The universe owes us no spectacle, and yet we find ourselves in the front row of one. Such moments remind us of how deeply the moon is woven into our history. Ancient calendars were built around its cycles. Rituals and festivals tracked its phases. Farmers planted and harvested by its glow. Its pole-shaped tides, which in turn shaped coastlines and ecosystems. It steadied Earth's tilt, giving us seasons stable enough for life to flourish. Without the moon, our world might have been too unstable for civilizations to rise. It is not just a companion in the sky. It is an architect of possibility. Yet the moon is also a trickster, forever reminding us that we do not know as much as we think. For centuries, people believed moonlight was cold, that it could stunt plants or chill the body. The belief lasted well into the 19th century, with experiments that seemed to show moonlit thermometers reading lower than those in shadow. We now know reflected sunlight cannot cool. It adds warmth, however slight. But the persistence of the myth is telling. We watched the moon so closely that we convinced ourselves it shaped more than it did. And, in a sense, we were not wrong. It shaped tides, rhythms, and cultures. It shaped thought itself. The moon has also tested us with vanishing treasures. After Apollo, goodwill samples of moon rock were gifted to nations worldwide. They were rare, older than Earth's oldest mountains, priceless in science and symbolism. Yet many have since disappeared, stolen, sold on black markets, lost in fires, or simply misplaced in storage. Today, more than half remain unaccounted for. It is oddly human that something as precious as another world's stones could end up forgotten in a drawer or sold to the highest bidder. Our relationship with the moon is marked not only by awe, but also by clumsiness. Even so, the moon continues to give perspective. To look at it is to see permanence. Our cities may crumble, our monuments erode, but footprints on the moon remain. Dust preserves them for millions of years. A flag bleaches in the sun, but does not fall. Tools lie where they were dropped in 1969, frozen in time. The moon is not a place of forgetting. It remembers everything. In its silence, it becomes a record of us, more enduring than most of what we build on Earth. And that perhaps is its greatest gift. Not its ice, not its minerals, not its potential as a base, but its role as a witness. It has watched every culture look upward, every poet describe its glow, every scientist measure its orbit. It has steadied our climate, stretched our days, pulled our tides. It has outlasted empires and languages, and it will outlast us too. The moon has been here since life began, and it will remain after we are gone. Yet it is not eternal. It had a beginning, and it will have an end. There was once a time when Earth spun without it. There will be a time when it drifts too far to eclipse the sun. In between there is us, living in the brief moment when the moon seems steady, perfect, and constant. It is a reminder that permanence is an illusion, and that beauty often lies in transience. Look up tonight, and you will see the same face seen by your ancestors. But know, too, that behind that face lies another, hidden for most of history. Beneath that face lies a fractured interior. Around that face flows an invisible tale. Within its dust hides water. Across its surface flicker unexplained lights. The moon is not what we thought. It never was, and that, more than anything, is why it continues to hold us. Imagine standing at the edge of a tide pool, waves folding in and out, the water shimmering silver under the full moon. The rhythm feels timeless, as though this pull has always been here. Yet the tides you see are not just the work of the ocean and the wind. They are the signature of gravity stretching Earth itself. Without the moon's steady pull, the seas would move differently, perhaps violently. Life that once emerged in tidal zones, nurtured by cycles of wet and dry, may never have found a foothold. The moon was not only a companion, it was a midwife to evolution. The same gravitational embrace that raises seas also slows Earth. Billions of years ago, our planet spun faster, days shorter than 10 hours. The moon tugged, dragging on the oceans, creating friction that bled energy away. Slowly, Earth's rotation eased. Today, each day is 24 hours long, but not permanently. It lengthens by milliseconds each century, a gift of the moon. It stretches time itself. Were it not for this slowing, human life might have unfolded on a planet where the day was too short, the rhythm too quick. One wonders if thought itself might have raced faster, if civilizations would have burned brighter but shorter. Of course, the moon does not give without taking. While it lengthens our days, it steals our distance. As the oceans pull back on it, the moon slips away centimeter by centimeter. This delicate dance will one day separate us, but not for billions of years. By then, continents will have moved, stars will have shifted, and perhaps humanity will no longer stand here to watch. Still, for now, we share a unique intimacy, so precise that it creates eclipses, so balanced that it shapes seasons, so quiet that it goes almost unnoticed. Cultures have noticed, of course. To the ancients, the moon was never merely an object. It was a goddess, a god, a clock, a mirror of fate. In Mesopotamia, she was seen a deity of wisdom. To the Greeks, Selene drove a chariot of silver light across the night. To the Chinese, Chang'e floated there eternally, accompanied by a jade rabbit pounding elixirs of immortality. The Maya built observatories to track its cycle, aligning rituals to its phases. Everywhere, people saw stories in its glow. Some saw protection, others saw madness. Some saw fertility, others saw death. The moon was always more than rock. It was meaning itself. Those meanings often took strange turns. In medieval Europe, it was thought that staring too long at the moon could unbalance the mind. The word lunatic still carries the mark of that belief. Werewolves, said to transform under its light, were a warning not to trust the night. Farmers, however, embraced it, timing plantings by its phases. Sailors studied it, guiding ships by the tides. Lovers met beneath it, their romances stamped with its glow. It was a source of dread, of hope, of superstition, of poetry. The moon was whatever humans needed it to be. Even today, myths cling stubbornly. Some believe the moon affects sleep patterns, that dreams grow stranger when it is full. Studies show mixed results, yet the persistence of the idea is telling. We still treat the moon as a companion with moods, as if its brightness seeps into our minds. And perhaps, in a way, it does. Its cycles mark our nights so reliably that it is no surprise we imagine it shaping our own rhythms. But beyond myth lies practicality. The moon has always been a tool for measurement. Ancient calendars were lunar, with months tied to phases. Eclipses were recorded with precision, their predictions a mark of advanced knowledge. Even now, timekeepers monitor the moon's orbit to refine Earth's rotation records. Without it, our clocks would drift, satellites would misalign, and GPS would falter. This quiet companion continues to order the modern world, silently keeping watch as it once ordered ancient fields and festivals. And yet, for all this reliance, the moon still resists our full understanding. Consider the far side. For millennia, no human eye had seen it. It was hidden, locked by tidal forces, always turning the same face to us. Only in 1959, when a Soviet probe sent back the first images, did we finally glimpse its other side. To our surprise, it was nothing like the familiar face. Instead of wide, dark plains, it was battered, rugged, scarred with craters. Why the difference? Theories abound. Some suggest a thicker crust prevented lava flows from spreading there. Others hint at ancient impacts that altered its structure. Whatever the reason, the far side remains a reminder. What we see is never the whole truth. The far side is not completely silent. Radio astronomers dream of placing telescopes there, shielded from Earth's noise. It is the one place in the solar system where radio waves from the cosmos could be heard without interference. Imagine listening to whispers from the dawn of time, free from the static of human civilization. The far side, once a mystery, may become a window. As we learn more, we find that the moon is not an isolated rock, but part of Earth's larger story. Evidence suggests it was born of violence, when a Mars-sized body struck Earth in the solar system's youth. The collision tore away molten fragments that coalesced into the moon. In that sense, it is Earth's child, born of trauma, yet destined to shape its parent. We carry the same isotopic fingerprints, confirming our shared origin. To look at the moon is to look at Earth's reflection, cast into the sky. This shared history also explains why the moon is so tantalizing for exploration. It is not foreign, it is family. Its rocks record the history Earth erased. Its craters store the timeline of impacts that shape both worlds. Its ice preserves whispers of ancient comets, carriers of water, and perhaps life's ingredients. To study the moon is to study ourselves, a mirror not just of light, but of origin. And so humanity has returned to it in thought, if not yet fully in presence. Plans unfold for bases near the poles, where ice hides in shadow. Telescopes may peer into the past from its far side. Factories may one day refine its dust into bricks and glass. The moon, long a place of poetry, is becoming practical. Yet its mystery remains. Perhaps that is why it continues to entrance us. If it were fully understood, it might lose some of its hold. But every answer leads to new questions. Every crater, every anomaly, every unexplained light keeps the fascination alive. The moon is generous in mystery, always offering enough to keep us looking up. And so, when you see it tonight, know that you share in a tradition stretching back to the first humans who looked skyward. You see the same glow that guided travelers, frightened villagers, inspired poets, and tested scientists. You see not only rock and dust, but the story of Earth itself, written across a silver sky. The moon is both familiar and unknowable, both ancient and ever new. And it waits, patient, for what comes next. Picture a quiet lunar plain under eternal twilight. The horizon curves close, the sky black and star-strewn even at noon, the sun sharp and unblinking. The ground is pale gray, a powdery dust that clings to everything. Your footprints linger undisturbed, as though carved into memory itself. This is the place humanity once visited briefly, leaving flags and instruments, then retreated. Yet it calls us back, softly, insistently. For years, dreams of returning were painted in grand visions, then delayed by budgets and politics. But now, once more, plans sharpen. Agencies draw blueprints for lunar bases. Companies sketch designs for habitats buried under regolith. The idea is simple. Live on the moon, not just visit. Harvest its ice, shield from its radiation. Build a foothold on a world so near and yet so foreign. To some it sounds ambitious. To others, inevitable. The poles are the favored choice. Unlike the equatorial deserts of Apollo, these regions hide permanent shadows in deep craters, where the sun has not touched in billions of years. Within those shadows, scientists suspect vast reserves of water ice. Ice is more than survival. It is possibility. Melt it to drink. Split it into hydrogen and oxygen to breathe. And more daring still, use it for rocket fuel. Suddenly, the moon is no longer a barren rock but a station, a gateway to the solar system. Yet living there is not easy. The surface alternates between two extremes. Searing heat when the sun is up, brutal cold when it is gone. Radiation seeps constantly, unblocked by atmosphere or magnetosphere. Dust, fine as smoke and sharp as glass, sticks stubbornly to suits and gears. Even something as simple as breathing requires layers of engineering. In this way, the moon humbles us, reminding us that survival itself can be extraordinary. Still, we persist, for there are advantages. Unlike Mars, the moon is close. 3 days travel, not months. Communication delay is seconds, not minutes. Supplies can be ferried, emergencies handled, return flights planned without the uncertainty of deep space. It is, in many ways, the training ground for humanity's next great steps. Think of it as a cosmic apprenticeship, preparing us for harsher worlds to come. There is humor in this vision, too. Imagine astronauts carefully raking dust to plant solar panels, only to watch them clog with clingy regolith faster than a kitchen counter gathers crumbs. Picture debates over lunar real estate. Who claims the rim of Shackleton Crater? Who sells moon views with Earth rising above the horizon? One can almost hear real estate ads. Quiet neighborhood, no atmosphere. Breathtaking sunsets every 14 days. The moon, once a stage for mythology, may become a stage for marketing. Humanity has a way of turning even the sublime into the practical. But beyond commerce lies science. The moon holds treasures no telescope on Earth can match. Its far side offers silence, perfect for radio astronomy, where faint signals from the cosmic dawn whisper across space. Imagine listening to echoes from the first stars, their light filtered through billions of years, caught by antennas resting on lunar dust. The moon could become the greatest observatory ever built, a listening post for the universe. Its surface also carries a record of the solar system's history. Unlike Earth, the moon has no weather to erase, no oceans to swallow, no tectonics to recycle. Each crater is a page in time, each rock a fossil of cosmic events. To walk there is to wander a library of impacts, a chronicle of violence that Earth itself has largely forgotten. By studying the moon, we learn not only about it, but about the threats and gifts that shaped our own world. There is also art in this return. Consider what it means to watch Earth rise above the horizon each lunar morning. Apollo astronauts described it as life-changing. The fragile blue sphere hanging in the black void, oceans and clouds shimmering against the emptiness. Some argued that those images, the Earth seen from afar, did more for environmental awareness than any speech. If more people lived on the moon looking back at their home, perhaps our sense of stewardship would grow. Or perhaps we would argue over who pays for oxygen tanks instead. Humanity is, after all, both inspired and endlessly quarrelsome. And yet, for all the practical plans and commercial ambitions, the moon retains its mystery. Some ask why we bother at all. Why build there when Earth has needs unsolved? But perhaps the answer is simple. Because we are restless. From caves to cities, from islands to continents, from oceans to skies, we have always expanded. The moon is not a distraction. It is the next horizon. And horizons have always pulled us forward, even when we did not fully know why. In thinking about the future, one cannot ignore the question of ownership. Who controls the moon? Treaties declare it the province of all humankind, a place beyond borders. Yet already nations plan missions, corporations draft contracts. Will the moon be shared or parceled out? Will it be a commons or another frontier for competition? Perhaps it will be both, depending on who arrives first. The moon, silent and indifferent, will not decide. That decision rests with us, fragile creatures arguing under its glow. Still, there is reason to believe cooperation may prevail. The challenges are vast enough that no single nation or company can solve them all. Building habitats, shielding from radiation, mining ice. These tasks demand collaboration. Perhaps, ironically, the moon may unite where Earth divides. In its barrenness, it offers neutrality. In its difficulty, it demands partnership. It might even be the stage where humanity finally learns the value of collective survival. And beyond survival lies vision. Imagine children born under lunar domes, their lullabies sung beneath the soft hum of life support systems. Imagine festivals timed not to earthly months, but to lunar days. Imagine schools teaching constellations from a sky no atmosphere blurs. Life would adapt, as it always has. New myths would grow, new rhythms emerge. The moon, once a mirror for Earth, could become a cradle of its own culture. In this way, the moon reminds us that exploration is never only about discovery. It is about reflection. Each step outward shows us more clearly what we are within. By leaving Earth, we understand it more deeply. By building on the moon, we confront our fragility, our ingenuity, and our tendency to turn challenges into rituals of progress. The moon is not only a destination, it is a teacher. So when you look at it tonight, glowing above rooftops or forests, remember that it is not just a companion in the sky. It is a future waiting patiently, as it has waited for billions of years. It is an invitation, silent but steady, offering itself as canvas, as classroom, as launchpad, as mirror. We have walked there briefly, but the story is not finished. The next chapters are unwritten, and the ink is lunar dust itself. The moon holds its silence, and we hold the pen. Imagine a night where clouds part just enough for the moon to shine through, its glow softened by drifting vapor. You gaze upward, and for all its calm beauty, the question arises, what exactly are we looking at? A familiar companion, yes, but also a puzzle. For all we know, there are still truths about the moon that remain veiled, resting quietly in plain sight. Take its size, for instance. Compared to Earth, the moon is unusually large for a satellite. Other planets host moons, but few resemble this balance. A world and its companion locked in such a dance that they seem almost like twins. Astronomers note that this relationship is rare. In fact, without the moon, Earth itself might not have life as we know it. Our tilt would wobble wildly. Our climate swing chaotically. The moon steadies us like a hand resting gently on a spinning top. It is not an exaggeration to say we owe our stability to its presence. Yet one wonders how fortunate, or perhaps how odd, that such a moon orbits us at all. Then there is the matter of its distance. By coincidence, the moon is about 400 times smaller than the sun and 400 times closer to Earth. The result, from our perspective, they appear the same size in the sky. This cosmic happenstance makes solar eclipses possible. Few alignments in nature are so precise. Some say it is just chance. Others smile and suggest the universe has a sense of theater. Either way, the sight of a total eclipse, daylight dimming, stars returning at noon, is a reminder that the moon's relationship with Earth is as mysterious as it is mathematical. But anomalies do not end there. Consider its density, lower than Earth's, suggesting it may lack a large iron core, or its crust, thicker on the far side than on the near side. A strange asymmetry not yet fully explained. Even its orbit defies simplicity, slowly receding from Earth at about 4 centimeters a year. Over time, this drift means eclipses will no longer align perfectly. The moon in its patient way is withdrawing. And one day, billions of years hence, our skies will change forever. And then there are the whispers, the theories that range from unorthodox to outright uncanny. Some writers point out that the moon rings like a bell when struck. During Apollo missions, seismic sensors left behind recorded reverberations after impacts, vibrations that lasted far longer than expected. To some, it hinted at hollowness. To scientists, it simply revealed a complex, fractured structure unlike Earth's. Still, the phrase, "the moon rang like a bell," persists, rolling around campfire conversations and conspiracy corners alike. Others speak of odd lights, glowing mists, and transient flashes seen on the lunar surface. These events, called TLPs, transient lunar phenomena, have been reported for centuries. A flash here, a glow there, sometimes lasting minutes. Gas release, meteoroid impacts, or illusions in the eye of the observer. Explanations vary, but the reports continue, adding a faint shimmer of strangeness to the moon's otherwise predictable face. Perhaps most intriguing are the ancient myths. Cultures across the world wove stories of the moon's arrival. Some described it as if it had not always been in the sky. The Zulus spoke of a time before the moon, when Earth's balance was different. Greek philosophers hinted at a world once moonless. Of course, these are myths, not science. But myths often carry echoes of memory, however distorted by time. Could they be reflections of a distant epoch before the great impact that formed the moon? Or are they simply poetic musings? Humanity projecting stories onto the glowing lantern above? Even in modern times, the moon attracts speculation. Some suggest it was captured, not formed from Earth's debris. Others claim it was placed, a notion more mythic than scientific. For most, such ideas are curiosities, dismissed with a smile. But even dismissed, they reveal how the moon continues to occupy the border between the rational and the mysterious. Yet for all the anomalies, There is humor in our search for answers. Consider how often humans have blamed the moon for their troubles. Lunacy itself comes from luna, the Latin for moon. In old belief, its phases tug not only tides but tempers. Even now, emergency rooms report busier nights under full moons, though statistics stubbornly refuse to confirm the myth. Still, we find comfort in blaming the moon. Better to point at the sky than admit the chaos lies within us. And chaos or not, the moon does influence us in ways beyond tides. Farmers have long used lunar calendars, timing planting to its phases. Festivals across cultures celebrate its cycles. From mid-autumn feasts in Asia to harvest moons in Europe, lovers speak of moonlight, poets of silver beams, children of wishing upon it. The moon is woven not just into science, but into our language, our rituals, our art. It is both a fact and a symbol, never one without the other. This duality is what makes it endlessly fascinating. On one side, craters, regolith seismographs, orbital mechanics. On the other, myths, poems, superstitions. It is a world where geology and metaphor meet, where equations and emotions share the same stage. Perhaps that is why we cannot quite define it fully. The moon is not what you think, because it is never only what you think. It is more a mirror of our own need to explain, to wonder, to find meaning. And so, the quiet mysteries continue. Why does it hold more secrets than we expect of so familiar a neighbor? Why do we still argue over details? Still chase explanations for lights and asymmetries? Perhaps because, like the moon itself, truth is layered. Each crater we study opens another question. Each myth we trace leads to another echo. It may be that the moon will never give up all its answers. And maybe that is its final gift. Because if the moon were solved, if every shadow, every anomaly, every myth explained, it would cease to be what it has always been, a gentle source of wonder. The fact that mysteries linger ensures we keep looking, keep dreaming, and perhaps that is the point. The moon does not exist to be fully known. It exists to remind us that the universe, even close to home, is larger than our certainty. So the next time you step outside and see its light spilling across rooftops or rippling across water, remember, it is not just a rock orbiting Earth. It is a question, a companion, a stage for science and story alike. It has steadied our world, inspired our art, sparked our myths, and lured our explorers. And still it keeps part of itself hidden, as if to say, you may live beneath me for millennia, but you will never exhaust me. And that, perhaps, is why the moon is not what you think. Picture the moon rising just above the horizon, its edge distorted by Earth's atmosphere, glowing orange like a lantern lifted slowly into the night. It feels close enough to touch, though it is nearly 400,000 kilometers away. That strange familiarity, the sense that the moon belongs to us, yet remains forever out of reach, is perhaps why it has become the subject of both rigorous science and enduring mystery. For centuries, telescopes revealed its craters and seas, its mountains and plains. Astronomers charted every visible feature until maps of the moon were almost as detailed as maps of Europe. And yet, no amount of mapping silenced the whispers of anomalies. Observers saw lights flicker on the dark plains. Glowing streaks sweep across the surface. Some described mists rising briefly and then vanishing. Even respected astronomers, cautious in their words, noted events they could not fully explain. They called them transient lunar phenomena, TLPs for short. Recorded hundreds of times, the lights and mists remain unsolved. Was it gas venting from cracks? Impacts flaring in the night? Or perhaps a trick of Earth's atmosphere bending light just so? Science leans toward natural causes. But the mystery, like the lights themselves, lingers. And then there are the oddities discovered during the Apollo missions. When astronauts placed seismometers on the lunar surface, they recorded vibrations that defied expectations. During controlled impacts, spent rocket stages deliberately crashed into the moon. The sensors picked up quakes that lasted minutes, reverberating like a gong. On Earth, seismic waves die quickly, absorbed by water and shifting plates. On the moon, they echoed, as if the entire body were humming. Scientists explained it as a product of its dry, fractured crust, lacking the dampening water that Earth possesses. Logical, consistent, testable. Yet the phrase stuck. The moon rang like a bell. A metaphor, not a literal truth, but one that keeps resurfacing in late-night conversations where imagination likes to stretch its legs. There are, too, the tales of the moon's far side, the hemisphere forever hidden from Earth's view. For millennia, we saw only half its face, the same craters, the same seas. Not until 1959, when a Soviet spacecraft circled it, did humanity glimpse the other side. The photographs astonished scientists. Unlike the familiar near side dotted with dark maria, the far side was dominated by rugged highlands, with few seas at all. The crust there proved thicker, the features rougher. Why this asymmetry? Theories abound. Perhaps Earth's gravity altered the flow of molten rock, or impacts reshaped the balance. But the puzzle endures. Why should one side of the moon wear a smooth mask, while the other remains scarred and mountainous? Ancient cultures, for their part, did not need photographs to sense the moon's strangeness. Some myths spoke of a time before it appeared in the sky, as though it arrived suddenly, changing the balance of the world. In Mesoamerican lore, the moon was born from sacrifice, cast into the heavens only after hesitation. Among the Zulu, stories tell of two brothers who flung the moon into place. Even Greek accounts describe pre-lunar people. Are these fragments of distant memory, or simply the imagination of storytellers weaving meaning into the night? Hard to say. But their persistence across cultures makes the moon seem less like an ordinary rock and more like a stage upon which human wonder has always been projected. Then there are the structures, at least the ones people claim to see. Photographs from telescopes and spacecraft sometimes show peculiar shapes, geometric shadows, tower-like ridges, alignments that look suspiciously artificial. Most dissolve under scrutiny, revealed as tricks of light, ordinary boulders, or pixelated illusions. Yet the appeal of believing otherwise is undeniable. To think the moon might hide ruins or serve as an outpost transforms it from dead rock to silent witness of cosmic history. No scientist endorses this seriously, but still the images circulate, carried by curiosity more than conviction. And, in a way, that curiosity is the point. The moon invites us to look again, to question, to wonder whether we know as much as we think. Even the question of how it formed was not easily settled. For decades, theories competed. Capture, co-formation, fission. Did Earth snare the moon as it drifted by? Did the two form together from the same disk of dust? Or did Earth spin so fast that a chunk broke away? Each idea explained some things but failed others. Only the giant impact hypothesis, a collision with a Mars-sized body, gained wide acceptance, though it too leaves puzzles. If the moon came from Earth's mantle, why do some isotopes differ? If it was mixed with the impactor, why do others match so closely? The truth may be complex, layered, and still incomplete. And so while textbooks describe the impact as fact, scientists quietly admit details remain unsettled. Beyond science, The moon is simply woven into our daily rhythms. Its gravitational pull shapes tides, driving currents that have influenced life for billions of years. Some researchers even suggest tides helped life crawl onto land, creating pools where evolution experimented. Without the moon, perhaps we would never have left the sea. It is humbling to think this glowing disk above may have steered our very existence, not by intention, not by design, but by the quiet persistence of gravity. Still, we find ways to smile at its influence. Lunacy remains in our language, a relic of the belief that full moons stir madness. Even now, police and doctors joke, though data rarely agrees, that strange nights align with lunar phases. People swear by lunar calendars, planting by waxing moons, harvesting by waning. Romantic dinners are arranged under its glow. Songs fill with its metaphors. If you stacked every poem written to the moon, it might well reach its surface. That, too, is influence, though of a gentler kind. And perhaps that is why the moon is not what you think. For every fact we establish, density, orbit, composition, there remains a shadow of mystery, a suggestion that we have only traced its outlines. We send probes, we study rocks, we calculate with precision. Yet still, lights flash, myths linger, questions remain. The moon sits in a delicate balance. Enough science to ground it. Enough wonder to unsettle certainty. If you stand outside tonight and watch its glow soften the landscape, you will see what generations have seen. Beauty, stability, mystery. A neighbor we know well, and one we do not fully know at all. And maybe it is meant to be this way, a perfect mirror of ourselves, half seen, half hidden, always inviting another look. Imagine sitting in a quiet room, the blinds drawn, while a black and white television hums faintly in front of you. It is July 1969, and the world is gathered to watch men walk on the moon. Grainy images flicker, a ghostly figure in a bulky suit descending a ladder, a voice reminding us that this is one small step. The scene feels both impossibly distant and strangely intimate. After all, the moon is the same one you see outside your window, yet here it is under human boots. For many, the Apollo landings were the triumphant closing of a chapter, centuries of speculation answered by hard evidence. The moon mapped, measured, touched. But even in triumph, questions emerged. Some of them scientific, some cultural, some simply born of suspicion. Because when humans achieve something extraordinary, imagination insists on tagging along, whispering that there must be more beneath the surface. One of the strangest puzzles came from sound. During Apollo missions, astronauts reported hearing odd noises in their headsets when they orbited the far side of the moon, a kind of eerie space music, as some described it. The recordings, later analyzed, revealed strange radio interference, frequencies bouncing in unusual ways, perhaps caused by the interaction of spacecraft equipment. Engineers provided rational explanations, yet the phrase music of the moon lingers in the public memory, adding an almost supernatural echo to the scientific voyage. It is one thing for the moon to reflect sunlight, quite another for it to hum in the darkness. Then there were the photographs. NASA released thousands carefully cataloged, showing every crater and ridge where astronauts landed. Most revealed nothing more than rocks and dust, exactly what scientists expected. But some enthusiasts pored over them with magnifying glasses, claiming to find anomalies, shapes too straight, shadows too sharp, towers, domes, even supposed machinery. Experts dismissed them as tricks of light and film grain, but the claims refused to fade. To a public already enchanted by mysteries, the possibility that the moon housed secrets was irresistible. After all, If it had remained hidden for billions of years, why not hide something else? Even the flag, standing stiff on the lunar surface, invited whispers. To engineers, the solution was simple. A rod along the top kept it extended, so it wouldn't droop in the airless environment. To skeptics, its ripples looked suspiciously like fabric fluttering in a breeze. The lack of atmosphere, which explained the issue in the first place, was ironically what fueled the conspiracy. Rational minds pointed out the obvious. Imaginative ones preferred intrigue, and perhaps both had their reasons. For what is a moon landing without a little drama? The deeper anomaly came from rocks. Apollo brought back hundreds of kilograms of lunar material. Scientists studied them under microscopes, measured their isotopes, compared them to earthly samples. They were indeed ancient, older than most rocks found here, shaped by billions of years of exposure to cosmic rays. Yet some details proved curious. Certain isotopes suggested unusual origins, hinting that the moon might have a more complex story than a single giant impact. Again, explanations were offered, tested, refined. But the image of the moon as an archive of cosmic history, holding secrets locked in stone, only deepened. Outside the laboratory, culture spun its own myths. Some insisted the Apollo landings were faked on sound stages, complete with stage lights and painted backdrops. The irony, of course, is that such theories blossomed in part because the landings were so astonishing. To those who struggled to believe humans could cross space, denial became easier than wonder. Scientists groaned, governments protested, but the theories thrived in corners of late-night radio and tabloids. If nothing else, they proved that the moon, like a mirror, reflects not only sunlight, but also human doubt. Meanwhile, others took the opposite stance. Not that Apollo never happened, but that it revealed more than was shown. Rumors circulated that astronauts had seen things they could not report. Lights moving along the horizon, unidentified craft watching from distance. Transmissions cut short, video feeds glitching. Were these technical hiccups or deliberate edits? NASA maintained its position firmly. No UFOs, no hidden visitors, just science. And yet, the very act of denial fed speculation. Silence, people reasoned, often speaks louder than words. Beyond Apollo, probes continued their watch. Modern missions from China, India, Japan, and Europe mapped the moon in stunning detail. They found evidence of ice in permanently shadowed craters, deep in regions sunlight never touches. For colonization advocates, this was gold, literally in the form of water that could be turned into rocket fuel. But for the dreamers, it raised other questions. If ice survived, what else might linger in those untouched pockets? Could the moon, silent for eons, still hold something unknown, buried beneath shadows colder than outer space? And then there is the practical mystery of why we stopped going. Apollo was expensive, dangerous, and politically driven by a space race that cooled after its finish line was crossed. Rationally, the pause makes sense. Yet, emotionally, it leaves a gap. If we could go once, why not return? Why leave our closest neighbor untouched for decades? The gap itself feels suspicious to some, as though a warning had been received, a barrier quietly agreed upon. Again, no evidence, only imagination filling silence with stories. Meanwhile, science keeps nudging us back. Studies remind us that lunar soil holds helium-3, a rare isotope that could power future reactors. Its surface preserves the record of ancient solar activity, like pages in a book never erased. Its craters, vast and deep, hold clues to the history of impacts across the solar system. Rational, clear, compelling reasons to return. And yet each new mission proposed seems to carry an undercurrent of mystery. Perhaps this time we will find what has been hidden. Of course, gentle humor has its place too. Consider the odd fact that moon dust smells, at least according to astronauts. After tracking it into their landers, they noticed a scent, often compared to spent gunpowder. Imagine the first human outpost there, struggling not with radiation or gravity, but with the persistent aroma of a cosmic fireplace. We dream of lunar bases, but we may need cosmic air fresheners. Even mystery has a practical side. In the end, whether one leans on skepticism, science, or imagination, the moon remains fertile ground for both knowledge and wonder. It is studied in laboratories, photographed in high resolution, yet never quite surrendered to certainty. Conspiracies, curiosities, and cosmic jokes all orbit together, like dust around its surface. Step outside. Look up at the glowing sphere. You may see a rock, a relic, a scientific archive. Or you may see a lantern of secrets, a stage for theories, a mirror for imagination. Both views are true in their own ways, because the moon is not only what it is what we make of it, in stories whispered, in suspicions shared, in laughter at our own doubts. And perhaps that is its final mystery, how something so silent can inspire so much noise. Step outside on a clear night, and the moon looks unchanging, a silver disk that has watched over Earth for billions of years. Yet in boardrooms, laboratories, and launch pads across the world, plans are stirring to make that ancient light more than a distant companion. The quiet glow above is being reimagined as a place of futures, settlements, laboratories, stepping stones to worlds beyond. The idea of living on the moon is hardly new. Long before rockets, storytellers dreamed of it. Jules Verne sent his adventurers shooting toward it in giant cannons. Filmmakers of the early 20th century painted whimsical visions of moon men and mushroom forests. These fictions were fantastical, playful, sometimes absurd. Yet today, proposals for lunar bases are drafted not in novels, but in engineering papers, complete with budgets, blueprints, and legal arguments about property rights. The moon has become not just a muse, but a target. Why go back? The practical reasons are clear. First, resources. Scientists discovered that in the deep, dark craters at the poles, ice has survived for billions of years. Water on the moon means drinking water for astronauts, oxygen for breathing, and hydrogen for rocket fuel. In essence, ice makes the moon a cosmic gas station, a refueling stop on the way to Mars and beyond. Second, energy. Scattered through lunar soil is helium-3, a rare isotope barely found on Earth, but potentially powerful for fusion energy. Mining it could one day power cities without pollution, though the technology remains a distant dream. Third, science. The moon's airless, quiet surface is perfect for telescopes shielded from Earth's interference, allowing views of the cosmos sharper than any we have now. In short, the moon is not just a barren rock. It is a laboratory, a quarry, and a springboard rolled into one. And yet, alongside these practical motivations lies the intangible. Pride, ambition, curiosity. The desire to plant a flag not only in dust, but in history. Every great age of exploration has carried a mixture of necessity and prestige. Columbus did not sail merely for spices, nor did polar explorers march only for science. In each case, glory and rivalry lit the torches as brightly as practical needs. The space race of the 1960s proved that the moon is as much a theater of politics as of science. Today, new races are forming not just between nations, but between governments and private companies, each eager to carve their place in the lunar dust. NASA's Artemis program leads one such charge. Named after Apollo's twin sister, Artemis promises not only to return humans to the moon, but to establish a sustainable presence. The vision includes lunar habitats, rovers, and even a small space station orbiting the moon, known as Gateway. The timetable has shifted, as timetables often do, but the intent remains. This is not a brief visit, but a foothold, a chance to treat the moon not as a destination, but as a base camp for the solar system. China, too, has its eyes set firmly on the lunar surface. Its Chang'e missions, named after the moon goddess of Chinese mythology, have already landed rovers, returned samples, and scouted potential landing sites near the poles. Plans for a lunar research station in partnership with Russia add another layer of rivalry to the story. The United States and China, two giants of Earth, now cast their competition into the sky, each determined not to be left behind. And where rivalry thrives, progress often accelerates. Meanwhile, private companies are building their own rockets and modules, eager to sell their services to governments or anyone else willing to pay. Elon Musk's SpaceX imagines using Starship to deliver cargo to the moon at industrial scales. Jeff Bezos's Blue Origin dreams of constructing habitats that look less like dusty domes and more like gleaming space condos. Between corporate ambition and national pride, the moon is being written into balance sheets as much as poetry. Of course, these grand visions encounter humble realities. Lunar dust is not gentle. Sharp as ground glass, it clings to suits, scratches visors, and fouls machinery. During Apollo, astronauts returned to their landers covered in it, coughing as it floated through the cabin. Imagine building an entire city in such conditions. Engineers propose everything from magnetic filters to electrostatic brooms, but no one has yet lived long enough in that environment to be sure. Perhaps the first lunar suburb will spend more time sweeping than building. Radiation, too, lurks as an invisible foe. Without Earth's magnetic shield, the moon's surface is bathed in cosmic rays. A human living there would absorb doses far higher than what's safe over the long term. Solutions include burying habitats under meters of soil, constructing thick domes, or even using 3D printers to layer protective walls from lunar regolith. Picture astronauts as both explorers and construction workers, stacking bricks made from dust under the watch of the stars. It is a humble image, far from the gleaming science fiction towers of imagination, yet perhaps all the more human for its sweat and dust. Then comes the matter of ownership. Who exactly can claim the moon? International treaties state that no nation can own celestial bodies, that space is for all humankind. Yet history suggests humans are rarely satisfied with vague ideals when resources glitter in reach. Already, discussions about mining rights, resource sharing, and lunar law are surfacing. Will the moon be governed by committees or by the first boots that dig into its soil? The answer will shape not only law, but also the spirit in which humanity reaches outward. And yet, despite challenges, optimism prevails. Engineers sketch out habitats shaped like inflated domes, sealed with lunar dust. Artists imagine greenhouses under transparent roofs, where astronauts pluck lettuce grown under artificial sunlight. Children born decades from now may learn to write their names while staring out windows at an Earth rising over a gray horizon. The thought is whimsical, yet no more improbable than sailing ships once reaching unknown continents. What was once a fantasy of storytellers may yet become an entry in history books. Gentle humor has its place, too. Imagine the tourism industry, ever hungry for novelty, selling honeymoons on the moon. Couples in bulky suits stumbling through low gravity. Their first dance more of a bounce than a waltz. Souvenirs of rocks tucked into duty-free bags. Or consider sports. Basketball in 1/6 gravity, where even amateurs could dunk with ease. Perhaps one day, the most watched games on Earth will be played not on Earth at all, but in lunar arenas where every slam dunk takes 15 seconds. Progress may be practical, but humans rarely forget fun. Still, beneath all of this runs the quiet hum of mystery. No matter how many habitats we build, how many samples we return, the moon's deeper enigma remains. Why does it exist at all? Why does it guard Earth so closely, stabilizing our tilt, guiding our tides? Why did it form in just the way that allows life to flourish here? Living upon it may answer some questions, yet it will also sharpen others. For every dome inflated and every mine dug, new puzzles will rise with each Earthrise. So the moon calls us forward, not only with resources and opportunities, but with a timeless pull of curiosity. It is no longer only a silver lantern in the night, nor only a barren rock, but something in between, a place both known and unknown, practical and mystical, stubbornly refusing to fit into a single definition. And as plans unfold, we may discover that the most important thing we build, there is not a base, not a mine, not even a telescope, but a new chapter in our relationship with the cosmos. Look up again. Tonight, the moon still floats silently, untouched by human hands for decades. Yet in the near future, lights may glow upon its surface. Domes may glimmer. Dust may rise from rovers. It may no longer be only the moon you knew, but something stranger, closer, more familiar, a neighbor not just in the sky, but in our daily lives. And whether we greet it with all laughter or skepticism, one truth will remain. The moon is not what you think. The moon has always been more than stone. For as long as people have tilted their faces toward the night sky, its pale light has carried meaning. Before telescopes, before science, before writing, the moon was already a character in the human story, a companion, a deity, a timekeeper, a mystery. Even now, when we can measure its surface with lasers and map in exquisite detail, the ancient symbolism clings. The moon refuses to be reduced to geology alone. In ancient Mesopotamia, the moon was Nana, later called Sin, a god who rode across the heavens in a boat of light. His waxing and waning were read as mood signs, even prophecies. The priests of Uar recorded lunar cycles on clay tablets, careful to note eclipses, for they believed the fate of kings might hinge on the moon's shadow. To them, the moon was not a passive rock. It was an active agent in the drama of human affairs. In Egypt, the moon wore many masks. Sometimes it was Thoth, the ibis-headed god of wisdom, who measured time and balanced the universe. Sometimes it was Khonsu, a youthful figure whose very name meant traveler. The moon's journey across the night sky was seen as a daily pilgrimage. A cycle of death and rebirth played endlessly. While the sun ruled the visible world, the moon governed the mysteries, the hidden, the realms of dream and intuition. Egyptians, master builders of calendars, looked to its cycles to shape rituals and festivals, ensuring that earthly rhythms mirrored celestial ones. In India, the moon became Chandra, a shining god who rode a chariot pulled by 10 white horses. He was both luminous and moody, associated with romance, growth, and the tides of human emotion. In Vedic hymns, Chandra was described as a nectar of immortality, a source of vitality to gods and mortals alike. Even today, Hindu calendars follow the lunar cycle, weaving ancient belief into modern practice. Weddings, festivals, fasts, all are guided by the quiet clock of the moon. In China, the moon glowed with a softer, more poetic light. Here was not only a celestial body, but a symbol of longing and reunion. The Mid-Autumn Festival celebrates the moon at its brightest, when families gather, eat mooncakes, and gaze at its fullness. Legends tell of Chang'e, the moon goddess, who drank the elixir of immortality and floated upward, leaving her beloved behind. Alone on the moon, she became a figure of beauty and melancholy, a reminder that love and loss can stretch even across the heavens. When Chinese rovers land on the lunar surface, they still bear her name, a seamless fusion of myth and modernity. For the Greeks, the moon was Selene, a goddess who drove her silver chariot across the night. Her Roman counterpart was Luna, from whose name we inherit words like lunatic, a reminder of the ancient belief that the moon could stir madness. Aristotle speculated about its influence on tides and minds alike. Physicians in medieval Europe echoed the thought, linking phases of the moon to illnesses, bleedings, and temperaments. Whether or not science supported it, the belief endured. The moon, in its mystery, touched not just oceans, but human behavior. The Aztecs and Maya watched the moon as both calendar and myth. Their astronomers carved stone records of lunar cycles, timing agriculture and ritual to its phases. In their mythology, the moon was sometimes a rabbit, sometimes a goddess, always vital. The story of the rabbit and the moon persists even today across cultures from Mexico to Japan, where children are told to look up at the mottled surface and find its outline. The same craters that scientists map with coordinates are seen by others as ears and whiskers, a cosmic pet frozen in shadow. And in cultures without cities, without stone monuments, the moon still reigned. Nomadic peoples on the steppes, hunter-gatherers in forests, islanders on vast seas, all turned to the moon for guidance. Its cycles marked time when no written calendar was at hand. Its light guided migrations and hunts. Around countless fires, stories were told of how the moon was born, stolen, broken, or pursued. In every tale, the moon became not just an object, but a personality woven into the fabric of daily life. Even in Christianity and Islam, faiths often thought to focus on other symbols. The moon holds place. The Islamic calendar is lunar, its months beginning with the sighting of the crescent. Ramadan, Eid, and the pilgrimage of Hajj are tied to the moon's rhythm. Mosques are crowned with crescents, shining reminders that even in the age of skyscrapers, the moon remains a clock in the sky. Christianity, too, inherited lunar echoes. Easter, the central feast, is calculated not by the sun alone, but by the full moon following the equinox, a festival of resurrection timed to a cycle older than any church. What is striking is not simply that cultures worshipped or measured by the moon, but that they did so with such consistency across the world. Without contact, peoples from China to Mexico, from Mesopotamia to Polynesia, found in the moon a mirror of their lives. Its phases mapped onto birth and death, growth and decline, longing and fulfillment, perhaps because it is the one celestial body that visibly changes. The moon taught humanity to see time not as static, but as cyclical. It reassured us that endings are not permanent, that light returns after darkness. Yet the moon also carried shadows of fear. Eclipses, sudden and dramatic, were read as omens of doom. Inca priests banged drums and shouted during eclipses, hoping to scare away jaguars, believed to be devouring the moon. In Europe, farmers feared them as harbingers of famine or war. Even now, eclipses stir awe as crowds gather with cameras and telescopes. Science explains the geometry, but the old unease lingers, the sense that when the moon disappears, something fundamental trembles. Gentle humor sneaks in here, too. Imagine medieval villagers staring at a red eclipse, muttering that it must be the work of witches, while somewhere an astronomer quietly scratches diagrams in the dirt, trying to explain angles and shadows. Or picture ancient hunters pointing at the rabbit shape on the moon, inventing elaborate tales of how it leapt skyward, only for future scientists to label the same marks as basalt plains and craters. Humans are nothing if not creative in naming shadows. And through it all, the moon became a symbol of love. Poets compared faces to its glow. Lovers whispered promises under its light. Songs filled with moonlight and longing echoed across centuries. From Shakespeare's verses to modern pop lyrics, the moon has been cast as confidant, witness, and accomplice in romance. Perhaps because it appears when the world quiets, when hearts grow softer. The moon has always been a natural companion to intimacy. Even in today's secular world, the moon's cultural weight remains. Its image fills tattoos, album covers, movie posters. It shapes metaphors for mystery, madness, femininity, cycles, distance, dreams. We may send robots to drill its soil, but in language and imagination, it still belongs to myth. You cannot strip the moon of its poetry any more than you can strip the sea of its horizon. So as humanity prepares to build habitats and minds, it is worth remembering that the moon is not simply a frontier of resources. It is a frontier of meaning. Every dome we inflate, every rover we send, will settle on soil already crowded with gods, rabbits, lovers, and legends. Colonists of the future will not walk on empty ground. They will tread on layers of myth as deep as the regolith itself. Perhaps in their spare moments, they will still look out at Earthrise and whisper old stories, weaving new myths atop the old. For the moon is not only what science reveals, nor only what culture imagines. It is both intertwined. It is crater and goddess, dust and dream, fact and fable. It is the oldest clock we have, and the newest destination we seek. Above all, it is a reminder that humans cannot live by physics alone. We live by symbols, by meaning, by the light we cast upon the dark. Tonight, as it rises once again, remember, you are not just looking at a rock. You are looking at the mirror in which humanity has always seen itself. Imagine yourself under a clear night sky. The world around you has gone quiet. Traffic fades. Lights dim. Conversations drift into silence. Above, the moon waits. Not dazzling, not fiery like the sun, but steady, patient, and familiar. Its face has looked down on every human who ever lived, from the first wanderers who painted animals on cave walls to the astronauts who left footprints on lunar dust. In its pale glow, time feels both endless and intimate. You're looking at something eternal, yet personal, as though it has been placed there just for you. If this sense of quiet wonder soothes you, let it stay. And if you enjoy drifting through these calm reflections, support this channel gently by liking and subscribing, so that more of these stories may reach you in the stillness of night. The moon is an object we can measure, its orbit, its mass, its age. It is 4.5 billion years old, born in violence when a young Earth collided with a wandering planet. Out of chaos came order, and out of fire came the companion that steadies our tides. That is the language of science, careful and exact. Yet the story does not end there, because science alone does not explain why we feel drawn to it, why people still step outside and lift their eyes when it rises. It is not merely rock. It is memory. The moon holds the stories of everyone who gazed at it, prayed to it, sang beneath it. Each crater is an archive of impact stretching back billions of years, but also a canvas for human imagination. One person sees a rabbit, another sees a face, another sees only circles of shadow. The moon is not what you think, because what you think is shaped by who you are. A poet sees a mirror of longing. A sailor sees a compass. A farmer sees a calendar. A scientist sees a laboratory. The moon becomes all of these at once because it sits at the intersection of the measurable and the meaningful. In the 20th century, humans did what once seemed impossible. They crossed the void and touched the lunar surface. The Apollo astronauts described it as gray, barren, silent. Yet in their voices there was even reverence. One spoke of magnificent desolation, another of the fragility of Earth hanging in the black sky. They brought back rocks, dust, and data, but they also brought back perspective, that our world is small, delicate, and luminous against the dark. The moon, in its stillness, taught us to see ourselves. Future missions will return with robots and eventually people, building bases, mining ice, testing technologies. The moon will become a place of work, but beneath the machinery, its other role will remain. No astronaut, no engineer, no miner can step onto its soil without carrying myths in their mind. Whether they whisper them or not, the old gods, legends, and songs will be there. Humanity never arrives empty-handed. It arrives with symbols. The moon is not only a world to conquer, but a mirror to remember ourselves by. Consider the strange fact that the moon is just the right size and distance to cover the sun perfectly during an eclipse. If it were a little larger or a little smaller, eclipses would be partial, less dramatic, less moving. Instead, we live in an era where the moon fits exactly like a lock to a cosmic key. It is coincidence, say scientists. To others, it feels like design. Whatever you believe, the result is the same. People travel across continents to stand in the shadow of the moon, to watch day turn into night, to feel a chill of wonder as the sun's corona flares. It is science and spectacle in one, a reminder that the universe is not obliged to stir our emotions, yet often does. Even our language cannot escape lunar influence. Words like lunacy month, moonstruck, and even honeymoon trace their roots back to it. The moon has been stitched into our speech as thoroughly as into our skies. It shapes metaphors of change, of cycles, of hidden sides. We speak of dark sides, of phases of waxing and waning. Without even noticing, we are echoing its rhythms. Our very sense of time is written in its glow. There is humor in our attachment, too. Dogs howl at it, poets sigh at it. Scientists shrug at superstition, yet still step outside to admire it. We have invented everything from moon cheese to moon rabbits, from lullabies to space stations, all because one gray sphere continues to tug at our imagination. The moon has no atmosphere, no life, no rivers, no forests, and yet it is alive in us. That may be the most surprising truth of all. As you rest now, picture the moon not only as it is, but as it has always been, a silent witness. It has seen continents drift, glaciers spread, empires rise and fall. It has seen humans kindle their first fires, build their first temples, write their first poems. It has seen us at our smallest and at our greatest, and through all of it, it has never turned away. It faces us with the same side, always. Loyal, patient. A companion who does not speak, but does not leave. Perhaps that is why we feel something more than science when we look at it. The moon is constant in a world that changes. It is the night light of the earth, the lantern that follows us through time. Long after cities fade, after technologies crumble, it will still rise. And whoever stands then, barefoot or armored, will still lift their eyes and feel what we feel. Wonder, comfort, mystery. The moon is not what you think, because it is never only one thing. It is a rock, a god, a myth, a mirror, a teacher, a friend. It is ancient, yet always new. It is silent, yet endlessly speaking. Above all, it is a reminder that in a universe of fire and void, there is still light to guide us through the night. So when you next see it, pause. Let its pale glow calm you. Let it remind you that you belong to a story older than any nation, older than any language, older even than civilization itself. You are part of the same story that began when our ancestors first tilted their heads back in wonder. You are part of the great conversation between earth and sky. And if this quiet reflection has carried you gently, let it linger. Support this channel softly by liking and subscribing, so more of these calm journeys may find their way into the night. Close your eyes now. The moon is still there, waiting. It always will be.